spoken to nearly all of you that are here in this workshop. I did the GIS assessments for each of the local jurisdictions. To start off with, I will mention that Jessica Jimenez with the state is not able to join us this morning. So the information that she was going to cover at the beginning of this workshop will be covered on Wednesday afternoon during our session. So she will be available then and will provide all of that information at that time. And she does extend her apologies for not being able to join today. Also with myself is Brian Coolidge and Cheryl Benjamin with AppGeo. Cheryl is going to be doing a majority of the presentation. I will be joining again in a little bit when we cover the quality control portion. With that, Cheryl, I think our next slide is the agenda. Again, the Wisconsin-specific project information, Jessica Jimenez will be covering that on Wednesday. Then Cheryl is going to dive in right after I am done speaking here with the GIS data usage for NG9-1-1. And then she will go on to talk about the technical standards in the document that was published. Then dive into some parsing examples with NENA compliant fields, and then end with best practices. So with that, Cheryl, I am going to turn it over to you. I am also going to turn my camera off to conserve bandwidth. So thank you, everyone, and welcome to the workshop.
Thanks, Jessica. So the first part of today's technical session, we're going to discuss how GIS data is used in NextGen 911. So I want to do a brief reminder first of what NextGen is. So instead of calls being routed through your trunk circuits, routing is now going to be done through an IP network. It's going to be able to process all types of emergency calls, not just voice, but also text messages, photos, and video. It's also going to allow for interoperability so that you can change your calls and switch them to your neighboring communities, but not just the ones across your border, but in your regions, across the state, and even across state lines across the country. It's going to allow for a great amount of interoperability. Also, your wireless callers, the location that comes in is going to have a much greater location accuracy. Instead of just having a cell tower in a sector, you're actually going to be able to get an XY location of where they are. And of course, the most important thing, that it's going to rely on GIS data for call routing and handling. And that's why we're here today. We're going to be talking a lot about GIS data. So I have this little graphic I made up, and I like this because it really points out that there's three foundational elements that are needed for NextGen. You probably heard quite a lot about the ESI net, that's your broadband network that connects the PSAPs and it hosts the core NextGen 911 services. And then we have your GIS data, and that's how calls are going to be routed using that GIS data to get the caller to the correct PSAP. But then none of this really can work without your people and agreed upon policies and standards. And of course, you have to have adequate funding to support these. So I'm going to go into a detailed discussion about where GIS data is used and how it's used in the call routing process. And there's a lot of acronym soup that we're going to go into. So these little acronyms that you see here, I'm just going to briefly go over them here so I don't have to spend a lot of time on them on the individual slides. So when you see border control function, think of that like an internet firewall. Your emergency call routing function, now that's a functional element on the NextGen system, and it's going to compare the GIS data and determines what PSAP should actually receive a call. Your emergency services routing proxy, think of that like a traffic cop on the ESI net, and that's looking for emergency calls, and then it ushers them through the ESI net. Your geocode service will provide geocoding and reverse geocoding services. Your location information server, it's a list of service provider subscribers. And then location validation function, you may have heard of that before. That basically validates those subscriber addresses before they would ever even dial 911. You have to make sure that their address is going to be able to be found should they dial it. The MSEG conversion service, now that's a service that's going to convert between your legacy MSEG and the new PIDFlow element, which I'll talk about in a second. The mapping data service, it's a service that provides an out-of-area map, and that's because you can't store a map of the entire country on your local system. Next generation 911 core services are the base set of services on an ESI net that are needed to process a 911 call. And then here's this PIDFLO. That stands for Presence Information Data Format Location Object. That's a format for sending location information in an XML schema through the next-gen 911 system call routing process. And policy routing function, that's a functional element that's going to determine the next hop in a next-gen 911 system for a call, and it's based upon policy routing rules that are set up locally. Your public switch telephone network, that's your communication system today for routing your E911 calls. Spatial interface, that's an interface between the GIS data and then those functional elements on the ESI net that consume the GIS data. And then lastly, your voice over internet protocol, that's the technology that's going to allow the delivery of calls over the IP network. Okay, so let's dig in. Let's first start talk about where GIS data is used in NextGen 911. This is, first of all, very, very simplified graphic. If you've been to any of the NENA conferences or any of the webinars that they've done, some of their technical folks have graphics that have 2 or 3 times the amount of icons and arrows and all kinds of things pointing on them. But I boiled this down to something a little bit more simple so that we can really focus on where GIS data is used. So we're going to start, and GIS data is built and maintained locally by counties, and then it's going to be brought together and coalesced into your regional or statewide GIS management system. And that can be maintained by someone in local government, regional government, state government, or even a vendor. Then the QA/QC is performed on that GIS data when it comes in. But before that data can actually be used into a next-gen 911 system, it's going to be loaded into the spatial interface, the SI. And when it gets to the SI, there's going to be more QC that's performed, because now it's going to take those individual county data sets and bump them up against each other to make sure that road center lines snap to each other, that there's no unintentional gaps or overlaps in any of the boundaries. So there are problems that are found, there are QA/QC reports that are generated, and any issues are going to be returned back to those GIS data providers. And NENA actually has an entire document about that reporting process called the Data Management Requirements document. So once you do have data that's confirmed valid for next-gen 911 use, meaning all the critical errors no longer exist, the GIS data is then going to be provisioned into the location validation system, the LVF, so that before a carrier can even turn on the service for that new provider, they need to validate that that customer's address can be found in that next-gen 911 GIS database. Now that exact same GIS data, that's also going to be provisioned into the ECRF. That's the emergency call routing function. So that when a call is received from a device that has dialed 911, it can be routed to the correct PSAP. And then that same GIS data, it's also going to be used in the PSAP for your map display, call handling, and for dispatch purposes. And then lastly, GIS data is going to be a core component in some new services that were recently defined in I3 that I just mentioned, the MSAG conversion service, the mapping data service, and the geocode service. So as you can see, GIS data really is a major component and used quite a bit in all aspects of next-gen 911. We're going to now transition to looking at what happens in the location validation function. Again, this is before anyone even dials 911. Its carrier has a new subscriber. So customer service provider, they get a new subscriber. And the subscriber's location information is going to be stored in a PIDFLO format. Now that's a way to represent location information into an XML format. And they store that in the list, the location information server. That's in the service provider's realm. That's not something that you have to worry about. The service providers create the list. So the list has that PIDFLO format address, and it's going to query that location validation function, the LVF, with the subscriber's address to determine, is that address valid? Now the LVF, that's using that same local GIS data as the ECRF. So when that subscriber is going to dial 911, it's going to have to reference the exact same location that's in the LVF. So it's doing this pre-validation activity. The LVF, it's going to validate the location, and it's going to return confirmation as to whether or not the address is valid. Now, if it's not valid, that service provider has to work with the GIS data providers to determine why it's not valid. For example, is it a brand new structure? Maybe on the carrier side, the data input was incorrect, or the subscriber gave them wrong information, something was transposed. Now, this is all done upon the initial adding of that new subscriber. However, GIS data changes over time. So there are going to be needs to do a periodic revalidation of all those list records against the LVF so that if the GIS data does change, they can confirm that there is no issues that have come up because of that data change with the validity of the list records. So that's the location validation piece. Okay, now we're going to look at how a call is routed in a next-gen 911 system. And this gets a little bit complicated, so I'm going to walk through it a little bit slowly and try to explain it as we go through. So you have a 911 call that's sent from the device, and it's sent with its location in that PID-flow format. Again, that's the machine-readable XML format. And it's going to request an SOS service, and it's going to send it through the border control function into the ESI net. Now that SOS service, you see the little URN service.sos, that's called the Uniform Resource Name. And it's a service request that's going to mark that call as a 911 emergency call as it runs through the IP network. Now the Emergency Service Routing Proxy, the ESRP, remember that's your traffic cop. He's out there looking for those SOS calls. And they're going to recognize the SOS service request, and it's going to send that location in PID-flow format along with the SOS service request to the emergency call routing function, or the ECRF. So now the ECRF, this is where a lot of GIS activity occurs. It's going to use the GIS databases to determine which PSAP the location is within and the emergency service providers for that location. And it does this by performing a point and polygon query. So if you use GIS, you should be familiar with this. It's going to take that location that's in the PID-flow, and it's going to drill down through the PSAP layer and the emergency service boundary layers. Now, if the location is provided as a civic address, it's going to look at your site structure address points first. If it can't find an address point matching that address, then it's going to geocode the address to the road center lines, interpolating the location along the road where the civic address is located, and then doing the point and polygon query at that point. So the ECRF, it's going to take the location information, it's going to take the SOS service URN, and it's going to generate what's called a Uniform Resource Identifier, a URI. And that identifies a resource on the IP network on where to route the call. And basically, it's how it gets the call to the correct PSAP. So this process that takes the location information, gets a URN, and creates a URI, you may have heard called a phrase LOST, location to service translation. And that's what this is. This is the LOST protocol you may have heard of. Never really quite understood it myself until I really dug into it. I didn't make it up. It really is what they explain it. And when you hear LOST protocol, what I'd like to do is say it's a good way to remember what it is that it uses your GIS data to find out where you need to go so that you're no longer lost on your IP network. So GIS data gets you out of lost. Okay, so moving on. The ECRF, it's going to return that PSAP URI to the ESRP, your traffic hop. But before the traffic hop moves it along in the system, it first needs to check the policy routing function. And it's going to query it for any special rules that may alter the normal route of the call. And it's going to be based upon predefined criteria. For example, is there a known outage, a busy condition? Is there planned maintenance? Is there a special event, something that may change where the call should be routed to? So if a rule exists that's going to impact where the call will go, then the PSAP URI would be changed at that point. And then the 911 call is going to be sent with its location, either to the original PSAP that was identified, or if it was changed to that new PSAP in the PSAP URI, and it's going to go to the telecommunicator. Now that PSAP is connected to the caller, and they can receive at that point in time all kinds of voice, text, videos, images, and any other additional data. And this entire thing that I took a couple minutes to walk through, it's really all going to take less than a second to occur. In fact, we're told it should take milliseconds. So it's going to be basically invisible to both the telecommunicator and to the caller. Okay, so you're all probably saying, that's a lot to absorb. And I agree, it is a lot to absorb if you haven't seen it in this level of detail before. So I'm going to walk through it one more time, but a little bit faster. This will hopefully help solidify how this works. Okay, so you have your 911 call. It's going to be sent from the device with its location in PIDFlow format, and it's going to request that SOS service. And it's going to send it to the border control function into the ESI net. Now your ESRP, that's your traffic cop, is out there looking for help. And it says, hey, I can help you. And it's going to take the SOS service request in the PIDFlow format, and it's going to send it to the ECRF. The ECRF is going to do the point and polygon query. It's going to take that location and drill down through the PSAP layer and the emergency service boundary layers, and it's going to return that URI identifying the PSAP where to route the call. The ECRF returns that location with the PSAP URI to your ESRP, that's your traffic cop that will tell it where to go. The ESRP is going to check the policy routing function, and it's going to look for any special rules that are going to change potentially which PSAP should receive the call. And then it will change it or it will keep it the same and send it back out into the internet through the border control function to the correct PSAP. And then the 911 caller will be connected to that PSAP and they can start conversing. Any questions about that before I move on? Okay. So again, if you have any questions, I know we didn't mention it, feel free to drop it in the chat box. Both Jessica and Brian are monitoring to that, and they can stop me if we do get questions and we can catch up on them as necessary. Okay, so why do we actually need standardized data? Well, we all understand why GIS is needed and it needs to be complete and accurate in the next-gen 911 system. But we're also going to need standards so that next-gen can work as designed, so that it can provide interoperability and that 911 calls can be seamlessly transferred to any other entity. Now, NENA is the technical standard setting organization for 911. They have many, many standards out on their site. They're publicly accessible. Anyone can go and review them. And there are two that are key and critical to how GIS data is used. The first one, the NENA I3 standard for next-gen 911, has in it Appendix B, which explains the spatial interface. I3 in entirety, that's the master plan for how next-gen 911 is supposed to work. The NENA standard for next-gen 911 GIS Data Model, or they call it STA 006 for short, that's all about the GIS data. And that is also the document upon which the Wisconsin GIS Data Model is based upon. So in the GIS data model, it's going to define all of your GIS data layers that are going to support lots of functional elements. We already talked about location validation and geospatial call routing. And in addition to those next gen, it's still going to be used for your dispatch routing and your public safety mapping applications, your functionality within your PSAP. It provides for your required data structure for GIS, meaning all of their attributes, their format, and what are their allowable values or domains. So on a national level, the NENA standard does state that it allows locals to maintain your data in any local format needed for your day-to-day needs. It's not saying that you have to maintain data in this format in order to be NG9-1-1 compliant. However, when you present or provide your GIS data for use in a next-gen 911 system, it must be exported into this standard. And this can be accomplished simply through ETL processes in many, many cases, ETL being the extract, transform, and load processes. Now, Wisconsin also recognizes that some local data may need to be maintained slightly differently in order to work in its current CAD systems. Not all CAD systems are yet 100% NG9-1-1 compatible, and there's also other functionality they offer, so you may need to carry additional fields or other information. The important thing to note, though, that in this GIS data model, it's going to allow backwards compatibility with your existing E911 systems. So what that means is PSAPs that have actually gone and migrated to NextGen 911, they can still share their data information back with the PSAPs that have not yet migrated. And this is going to be really important as Wisconsin transitions to NextGen 911 because it's not going to occur overnight. It's actually going to be a multi-year rollout. It's going to take a little bit of time to get everyone there at the same time. It's not going to be doable. So next I want to just briefly talk about the different GIS data layers that are mentioned in the NENA GIS data model. And they're broken into 3 different categories. The first category are the required GIS data layers. And these are your layers that are absolutely necessary in order to be able to do the location validation and to do emergency call routing. And they're also critical for call taking and dispatch operations. So you have your road center lines, your site structure address points, your PSAP boundaries, emergency service boundaries, those are your police, fire, and EMS, and then provisioning boundaries. And I'll go into a little detail about them coming up. You may also hear about strongly recommended GIS data layers. Now, these may assist or improve the functionality of the LVF and the ECRF. So for example, if an invalid location is received during the call processing, these layers could help provide a best guess for the telecommunication to start with as to where the call is coming from. And this can be also layers that are extremely beneficial for your call taking and dispatching operations. Now, there are some upcoming changes in version 2 of the GIS data model regarding the landmark features, and I'm going to have a slide coming up a little while later today that I'll talk about them. And then lastly, we have our other recommended GIS data layers. And these are basically reference layers that are very useful for NextGen 911 and current E911 call taking and dispatching operations. So why we're here today, we're going to focus on the required GIS data layers for 911, and we're going to primarily focus on these 2, the road center lines and the site structure address points. We'll also talk about the GIS data model that's going to be used for your required GIS data layers that was created for Wisconsin. 2 things to note. Now, while most organizations have road center lines, they're really are probably not ready 100% for NextGen 911 use. And not everyone also has address points. There are a lot of places across the country that have not yet created them. And while they're required for NextGen 911, NENA has recognized that not everyone has them, but they wanted to flag them and have people start working on them and building toward them. So today we're going to discuss some of the best practices that were created for maintaining the road center line and site structure address points. And all the information that we're going to go through today, it's in that Wisconsin GIS Data Standards and Best Practices document. And that document we created last year. We worked on it from June to about October with the WILA NG9-1-1 GIS Task Force. And it was finally approved by the 911 Subcommittee in November 12th. And hopefully you've all had a chance to review it. The other layers we'll talk about today will be the PSAP boundaries. And those are the geographic area of where a PSAP has primary responsibility for a 911 call. The emergency service boundaries, again, your police, fire, and EMS. For those who've worked with emergency service zones, which are the unique combination of those 3, this is different. In version 1 of the GIS data model, these are separate layers to be able to do that point and polygon drill down. And then we're also going to be talking about the provisioning boundaries. And this, think of it like a geofence. It's a geographic area of whoever is responsible for the GIS data within that boundary. And they're the data stewards for that particular information. One thing to note is that GIS Data Model version 2 is going to be providing some more clarity regarding the emergency service boundaries. There's been some discussion recently about, is it really required that they be separate, or can they be combined when you provide them to your SI provider? Key thing to note, whichever way you maintain them, it really doesn't matter. You can maintain them locally however you need to, but when you create them and provide them to your SI provider, work with your core service provider and your SI provider to find out what they actually need. People have often asked, how long is this whole process going to take? So transition to Next Gen 911, it's not simply flipping a switch. It's going to take a while to get there, but the good news is a lot of work has already started. But because data development is going to take time, and if you're GIS professionals, you know that it does take a while to keep data up to date and maintained, you really need to be working on this now so that when your infrastructure is in place, you're going to have data that's Next Gen 911 compliant and ready for use. So your data right now might not be fully ready, but you want to at least start transitioning and getting it into the data model. There are some fields you may not currently carry, but you may be able to ETL them on. So for example, you have things like country, state, and county. You may not carry them locally, but it's simple to add them on through an ETL process. The other thing that I want to note is that during transition, there are some fields in the data model that are being carried. MSEG and ALI will still exist, but we also have some legacy fields that reference the information in there for use during this transitional period. The MSEG conversion service that I mentioned previously, that's one of those elements that will help and utilize these fields to transition calls from a current 911 system back into a legacy system, and also the reverse, a call from a legacy system that needs to be transferred to someone who's already a Next Gen 911. So that's kind of our background. We're going to switch into our next section, and we're going to talk about the actual technical standards document that was created. So hopefully everyone's taking a look at this, and our discussion today is intended to help reinforce the information that you've already reviewed. So in the document, if you look at the table of contents, there's several sections in it. The key sections being the actual Wisconsin NG9-1 data model. It's going to talk about all the required data layers, and then it gets into details about each specific field. There's also a crosswalk for those of you who might already be maintaining data in the WILA standard into the Wisconsin NG9-1 standard. There's a section that talks about impacts, about upcoming changes in NENA standards, and I'll go into a little bit more detail about that, and a section on quality control checks. A lot of times we've gotten questions about how do you parse street names and addresses, and so we have some pages of examples of how you do that. And we'll go into details today about how to do some parsing and give you some real life experience with that. And then the last part of the document actually talks about best practices for those road center lines and address points and gets into a lot of details about segmentations, how to put different attributes on them, and also some unique situations that you may run into and are not quite as common. So the GIS Data Standard that Wisconsin created is based upon NENA's GIS Data Model. As I've already mentioned, it's not intended to replace anything that you're maintaining locally. You're allowed to maintain data in whatever format you need. It's just when your data needs to be transitioned and provided to an NG9-1 system, this is the format, the required data schema, and all the associated fields that it has to have. And when you hear the word schema, it's the database structure of your data. The Wisconsin standard does include all the NENA fields, and then during our review and discussion, we also added a few Wisconsin specific fields that were being carried in the WILA data that were deemed important for NG9-1-1. Now for NG9-1-1 compliance, all of the fields must be carried in your data, even if you will never populate anything in them. Now your local data, it can be stored in any projection, and just kind of an FYI that NG9-1-1 requires WGS 84, and it's going to need to be transformed to WGS 84 before it's used in Next Gen 911. You may not have to do that. Your core service provider or your spatial interface operator may do that for you. But the thing to note with data transformation, it's very possible for it to cause errors in your data, very small shifts. So it's something that if you're going to do, you really need to be referencing a geodesist or other person who's very familiar with data transformation. So in the schema that's in the Wisconsin data model are a lot of information elements. And we're going to go through some examples in a moment. But the items that are specific to note is that there is an element name for every individual field. And what that is, it's just a basic description of what it is. Then there's a database field name. Now that's a standardized name that must be used in your NG9-1-1 GIS data. The field type, that's the attribute type is defined by the NENA Standard. The field width, that's the maximum field width that you can't exceed. If you do exceed it, it's going to get chopped off to whatever the maximum field width is in the standard. There's a section about inclusion, and it indicates whether or not you have to populate the field. Sometimes the population is mandatory, meaning there absolutely has to be something in there. It could be conditional, meaning if a value exists, it needs to be populated. And to give you an example, if you have a street name of Main Street, your pre-directional field is a conditional field. You would populate it if you had a pre-directional. Main Street is not having a pre-directional, therefore that conditional element would not be populated. And then lastly is an optional field. You may or may not choose to populate it. It's up to you. You still have to carry it, but you don't necessarily have to populate it. When you see domain, the domain is the set of all values for that particular field. Now, the table that's in the in the Wisconsin Standard is going to list either the allowable values for a domain, or it's going to reference a domain table where those allowable values can be found. And then if you don't have a domain that's listed, then any value that basically matches the field type and width and description can be populated in there. And then in the Wisconsin Standard, there's also a reference standard, and that's the standard that the data field is based upon. The majority of them are going to say NENA. Several others will also say that it was referenced on the WILA standard, and there's a few that are based upon US Postal Service or the Census Bureau. So the data element detail section, this follows a summary table, and there are 6 different groupings of fields. And if you use the WILA standard, we basically replicated the way that that standard was laid out for the next Gen 911 standard. So it has 6 sections. The elements that are related to identification, if they have related elements, those that are related to the address, those that are related to the area, functional elements, and then management elements. Now, every element that's in the summary table has a unique element number, and that's just basically based upon document structure. That's not a NENA thing. And we created them so that it's easy to be able to cross-reference from the summary table and to get to the detailed section about that particular field. And so that particular detailed field, and here's an example on the screen for the street name PreType, will have a separate table in it for each data element. And it's going to include all the same information that was in that summary table. So your data type, your width, your inclusion, your domain. And then it's also going to give a detailed description of the data element and provide some examples. And unless it's otherwise noted in that particular section for the field name, everything must be fully spelled out, and you also have to use title case. Now, everyone probably is rolling their eyes. Why do I have to, spell everything out? Well, it's going to be, remember, to be used in a database on the back end. You're talking machine-to-machine communication. There's no human element that's involved when the machines are talking to each other. So when you spell everything out, it's going to remove the confusion on what that abbreviation represents. Now, don't confuse what's stored in your GIS database with what the call takers and the telecommunicators are going to see on their screens or what they're going to type into their systems. That can all be customized with a software interface. And that interface can have its own set of shortcuts for folks to either see or type in, and it will translate on the back end and be able to talk directly with the fully spelled out versions in the database. One of the fields that I want to spend just one slide on that's very, very important is what's called the NENA Globally Unique ID. So every record in a GIS data layer, it must have a unique ID, and it has to be unique so that when you combine your data with your neighboring county's data, with the data across the state and across the nation, you have a unique ID that's specific to that feature. There's no duplicates. And it's created by concatenating a couple different fields. The first thing that's listed here is a conditional field. It's optional. You don't have to do this, but it's recommended. It's a prefix that's suggested of the layer. So if you have a PSAP boundary, it would say PSAP. If you have a layer about your police agencies, you would have law, one for fire, one for EMS, RCL for road center lines, etc. That makes it unique for actually an individual layer. The reason why it becomes critical for the 4 elements that I show here, PSAP, law, fire, and EMS, is because their database structure is exactly the same. How the PSAP is set up is the same as law, fire, EMS, and their NENA Global Unique ID field has the exact same field name. So if you start them all with a number of 1, you're going to have the exact same identifier in each of those layers. So having a prefix suggestive, at least of those 4 layers, is highly recommended. Now, the other pieces that are concatenated to that is your locally assigned unique ID. So whatever you're currently using today, you can continue to use that locally unique ID. And then to make it actually unique for your organization, everyone would concatenate the @ symbol and then their agency identifier. And an agency identifier, it's a registered domain name that's in the public domain name system. You may know this as DNS. Now, when you have these items put together, you'll notice in the examples at the bottom that there are different ways that you can have your local identifier. That locally unique signed ID you can continue to carry. You don't have to carry this entire NENA Global Unique ID in your individual locally maintained data. You just need to at least keep that locally assigned unique ID in there. And then through ETL, you could go ahead and update that by putting on the @ symbol and then what your DNS is. Right, now we're going to move into looking at each of the individual required layers and their schema. And the one that's going to take us the longest to walk through is going to be the road center lines. But a lot of the fields that are in here are used in the other layers. So we're going to start at the top, your identification elements, as you have your global unique ID. Now I just walked through that, so we're not going to have to go through that. And you'll see it is a mandatory field. In the road center lines, there are no required relate elements. So we'll move down into the address numbers. So it starts out with your address numbers, and there's prefixes and right and left froms and tos for them. And we're going to discuss those in more detail when we go over parsing street names, so I won't spend a lot of time on them. You notice that some of them are mandatory. You have to have addresses from and to on both the right and left sides. And you'll notice that those must also be whole numbers that are in there. Following that are all your street name elements. And it goes actually on to the second page. So you'll notice here there are a couple fields called full street name and abbreviated full street name. These particular fields, you'll notice over in the reference standard, just say WLIA. It does not say NENA. And it does not say NENA because these are not required NENA fields, but they're Wisconsin specific fields that during our discussions last year, it was thought that these would be very helpful. And so they were added into the Wisconsin schema for road center lines. The full street name, that's actually concatenation of all the fully spelled out street name elements. And the abbreviated full street name is the full street name, but it uses abbreviations for your directionals, your types, and your modifiers. And again, these fields came from the WLA standard. The next 4 fields that you see there with the red asterisks, you might recall I mentioned we carry legacy fields for transitional purposes. So these are the fields that are there to support legacy systems during their transition. Once everyone is in a full NG9-1-1 system, these legacy fields would no longer need to be maintained. Following them, we have your postal fields, you have your postal codes, and your postal community names. Those currently are optional fields. They don't have to be filled out, but if you have them, they may provide additional information that will help the telecommunicator if they get an invalid location that comes through the call. The next section in the table are your area elements, and these fields are all related to place names. And you can see at the top that several of them are mandatory, and you probably aren't currently carrying what country you live in, which state, or even which county. Again, you can add these on and populate them, or if you choose not to, you just have to be able to ETL or add them on prior to giving them into an NG9-1-1 system. Other fields include your incorporated municipalities, that would be like your cities and incorporated towns. Unincorporated communities, those are very similar to like your census designated places or other well-known areas. And then you have your neighborhood communities. You can find them in both cities and rural areas. In the cities, neighborhood might be a particular block area, a Little Italy, or some other locally recognized name. And in more rural areas, you might have a neighborhood community of a small subdivision that was built, or it could be a mobile home park with a named area. And then the last two fields that are shown there, additional code left and additional code right, those are used in Canada only. However, they have to be carried in the Wisconsin data set, but they'll never be populated. Again, this is all for interoperability. These would be two fields similar to the country and the state that could be ETL'd and added on at the end of your processing just before you give it to your SI provider. Okay, our last sections that we're looking at, your functional elements for road center lines consist of some optional fields. You have your one-way element, you have your speed limit, and you have your road class. Your management elements are related to dates. Now, date updated is the date and the time that the record was originally created or it was last modified. The next two, effective date and expiration date, they're very useful for when a plan change is known. If, for example, that you know a new road center line is being built and it's going to be open for service on a particular date, you could go ahead and put it in your system, but then say it's not effective until a certain date. So your system will ignore it until that effective date comes along. At the same time, if it was created in order to replace other roads, you can put the expiration date on those other roads so that without having to shut your system down and swap out data, it will automatically know when to no longer look at those dates where the expiration date has occurred and when to start looking at the new alignments when the effective date does occur. And then the last section that we're looking at here are 911 elements. So these are attributes that are carried on the road specific for 911 use. So the discrepancy agency ID, this is a field that's on every layer. And you might recall that when I talked about how the call data is brought in and loaded into the SI, that there's some QA/QC performed. The discrepancy agency ID is who is going to receive those reports that say, hey, there's a problem with your data that needs to be fixed. And that's the entity that's going to be responsible for either fixing the data or making sure that whoever the data they received it from gets it fixed. The next two fields deal with parity. That's your odd and even attributes on each side of a road center line for address ranges. And then you can see some more fields that have those red asterisks. Again, the red asterisks are those legacy fields that are being carried for your transition purposes. So you have your ESN left and right and your MSEG community name. And then down at the bottom, the last two fields that are there, validation left and right, are specific to road center lines. And it's for those areas where it indicates if your road center line should be used for that location validation process, or if she should only focus on using the address points for validation. So for example, there are some locations that have grandfathered addresses, which are out of sequence with the road center lines. And it's not just an odd address on the even side. This is a number that's like truly out of location. And this will help indicate that those particular segments should or should not be used in order to do that. You may want to force the actual location to be found from the address points on a particular segment and never look at the address ranges. So now we're going to transition and take a look at the site structure address points and what they look like in the standard. So the site structure address points layer contains many of the same fields as the road center lines. So I won't spend a whole lot of time on the ones I've already talked about. So starting at the top, you have a unique ID for road center, or excuse me, for site structure address points. That's your site in a globally unique ID. Now there is a relate element in the site structure address points, and that road centerline globally unique ID is the unique ID of the road centerline segment that the address point is associated with. And that's going to be important in the future as an alternate street name table is set up, so that any alias street name that's associated with the road segment using this relate could also be associated with the address points. So if you have Main Street and you also have US 62 over it or State Highway 45, it would recognize all those particular names with that site structure address point using this relate element. On the address numbers, you have your address number prefix, your address number, and address number suffix fields. Again, we'll go over them when we talk about parsing. The next set of fields here are related to your subaddress information. You have complete landmark name, you have milepost, building, floor, unit, room, seat. Those fields with the blue asterisks are noted because they're changing in a future update of some of the NENA standards, both the GIS Data Model and the Civic Location Data Exchange Format Standard. And I have some slides about them once we've gone through all of the required layers that I'll talk about them. Now the fields that follow it, the street names and street name pre-modifiers, they're all exactly the same as we saw in the road center lines, including the full street name and abbreviated full street name fields that came from the WILA standard, and those 4 legacy fields that we're carrying with the red asterisks for those data transitional purposes. And then at the end, we have the postal code, and since it is an actual point, we can add the zip +4, and lastly, your postal community name. Your area elements, again, they're exactly the same as your road center lines: country, state, county, incorporated municipality, your unincorporated community, neighborhoods, and additional codes. All exactly the same on your address points as they were on the road center lines. For functional elements, here we have some items that are a little different. Placement method. Now that's the methodology that's used for placement of the address point. And when we get into the best practices, we'll talk about that a little bit more. But basically it's talking about, is this point placed based upon a parcel centroid, based upon a structure? Is it a site that has no structures, or is it the access into that site or structure? Place type is an optional field, and that's a general category of the type of place that's represented by the address point. Now, it's currently optional. There has not been a lot of work done on this, and we think that there will be some future extension of this particular field. So I wouldn't really worry too much about it right now. One that might be important for some of your address points is the additional data URI. Now, this is a link to an online resource where you may store some additional information about that address point. And that might be something such as a floor plan for schools, or it could be a listing of chemicals that are stored in a chemical bulk storage tank. You want folks that have to respond to an emergency at that address to know a little bit more information about a particular school floor layout plan, or if you had like the chemical bulk storage, if they have a fire at a particular tank and you have a database listing of what's in all those different tanks, you would be able to use this online link to get to it and determine what is the information or the particular chemical in there and help those responders know how to better respond to that particular incident. And then at the bottom, we have a field called structure. And if you used the WILA standard before, this is where that field came from. And it indicates if the address point is actually associated with the structure. And then in our last section, the management elements, again, are exactly the same as we had in road centerline. So you had your date updated, again, when a feature was created or last modified, the effective and expiration dates, if you have features that you know are coming or leaving the system. And then in the last section, we have our 911 elements. Again, we have your discrepancy agency ID, who's going to receive the report if there's an error. You have our legacy fields that are being carried with the ESN and the MSAG community name. And then we have latitude, longitude, and elevation. Now, there's been a lot of work on the FCC regarding what elevation should represent. So the current definition of elevation, that may actually change in a future version of the GIS data model. And that's based upon work that's currently underway in a NENA 3D GIS requirements work group that's looking at the new FCC regulations. I'm going to move on to the PSAP boundaries file. Let's take a look at that. So this layer is going to represent the geographic extent of each PSAP's primary call taking responsibility. Now it's important to note the PSAP boundary is what's known as a service boundary, and it's going to contain the exact same structure as the emergency service boundaries. And you'll notice that its database field name right here, ES stands for emergency service, NENA Global Unique ID, is going to be exactly the same as we're going to see in the emergency service boundary layers. There are no relate elements, there are no addresses, and there's no area elements except for the state. So the fields that are most important in here are your functional elements, and some of these should be very familiar from when I talked about the call flow process. So we start with the agency ID, and your agency ID is the registered domain name for that PSAP. So for example, it could be waukeshacounty.gov. Then we have your service URI. So the service URI, that's the route on the IP network to reach the requested service. And you might recall that's how you got the route to the appropriate PSAP that was in the PSAP URI. Then you have your service URN. That's the service uniform resource name, and it identifies a particular type of requested service for which a route is needed. And as in the call flow earlier, we had URN service SOS that was identifying it as a request for emergency service. The next item that's in there is service number, and that would be the number, the phone number that you would basically dial on a phone to reach the requested service. So that could be 911, or it could perhaps even be an 800 number to reach poison control or some other service provider. The agency vCard URI, think of that like an electronic business card, and it's going to contain the contact information. So it's going to have that agency name, the contact phone numbers for that listed agency. And then that last functional element, display name, is just a name or a description of an entity that's offering the emergency services. So in the PSAPs, it would be the name of the PSAP, what you would want it to be displayed, for example, on a screen within a PSAP's telecommunicators screen. Now, all of these fields, when you populate them, it's highly recommended that you work with your NGCS core service provider to determine how they want them populated. They may have very specific requirements regarding these. Don't worry about populating them yet. Wait till you have a core service provider and you can work on it then. And then as you look through the rest of the elements, the management elements, again, date updated, effective date, and expiration date. And then in the 911 elements, the discrepancy agency ID. Who's the entity that an error would be reported to if there was a problem with something in the PSAP layer? So now we're going to look at those emergency service boundaries. And again, this layer is going to represent the geographic area for the primary responders of emergency service. As we just discussed, this database structure of the emergency service boundary layers is exactly the same as the PSAP boundary layer that we talked about. It contains the exact same fields and the exact same field names as the PSAP boundary, including that globally unique ID. Notice again, it's an ES, globally unique ID. So in GIS Data Model version 1, I mentioned earlier that it stipulates there has to be a separate layer for law enforcement, fire, and EMS when it's provided for NG9-1 purposes. That again is something that you need to consult with your core service provider, SI providers, that might be changing. Now, if you have other services, you might have Coast Guard, you might have forest control, you might have poison control numbers. If those services exist, you can create a layer for them, again, in this exact same structure. Let's move on to the last required layer, which is provisioning boundaries. Not much is in this layer at all. Again, this layer represents the coverage of area for which the GIS data providers are responsible for submitting GIS data for NextGen 911 use. It has a few basic levels, or excuse me, a few basic fields of which we've already discussed in our required layers. So we have the fields that are here. We've already talked about them all. It has a unique ID. It has your management elements for being date updated, effective, and expiration, and your discrepancy agency ID. Now, as far as what goes into this, as what is that geofence I mentioned, it could be the extent of a city, it could be a county, it could be a region with multiple cities and counties, or it's all of the areas that are served by a particular PSAP. The thing about this layer is when you're providing the data in it, you only want to include data within your provisioning boundary, and you want to make sure that you include all the data within your provisioning boundary. This layer is going to be very important for the spatial interface operator because they're going to use this data to coalesce the data from the other GIS data providers. And they're going to use it to make sure that there's no unintentional gaps or overlaps in the GIS data. So again, this is like a data management tool. Okay, so in the document, after you get through all of the Wisconsin NextGen 911 fields, there is a section that has crosswalk tables. And if local data is maintained in the GIS standard, many of those fields are also existing in the Wisconsin NextGen 911 standard, and they can be directly mapped without even any modification into the Wisconsin NextGen standard. Now, a few WILA fields might require some content modification before they can be used to populate the Wisconsin NextGen standard. And if so, those recommendations will be noted into the column on the right, the crosswalk notes. But you can see that the standard structure is what the WILA standard element name is and the field name, and then what's the equivalent NextGen standard element name, and what's the field name that NENA has set that must be used for usage within NextGen 911. I had mentioned that there are some future changes that are known. So implementation of NENA standards, it often identifies items that need improvement, clarification, or rework. It's very possible that wording in the standard was misinterpreted, or it might be lacking enough information in order to provide proper implementation of the standard. So every few years, NENA goes through a process where they reevaluate standards for their currentness and whether or not they need to be updated. There are also standards that have cross dependencies. And what that means is if a change occurs in one standard, it's going to impact other standards. And therefore, those impacted standards will also need to be updated shortly after the one standard is updated. And it's very important to keep an eye on what's happening with NENA standards and developments. If you're paying attention to what's happening in them or even participating in them, which is actually preferred because then you really have the inside scoop, it will give you a lot of lead time to prepare for any upcoming changes. Anyone is welcome to participate in the public review of a NENA document, but then if you were interested in an earlier look, it's recommended that you join a work group and you can be actually part of the solution. Maybe you'll see something that the folks who are creating it didn't realize, but you have that local knowledge and experience with something that you can bring to the table. Now, it doesn't require that you actually be a NENA member. You just need to be a subject matter expert. And as GIS professionals, you are all subject matter experts with GIS. Now, there are two standards that we do know have changes. NENA STA 004, the Civic Location Data Exchange format, and NENA STA 006, the GIS Data Model. Those two are pretty closely tied together, and there are upcoming changes to be aware of. So I'm going to talk briefly about them. In the CLDXF document that just went out for a public review not that long ago, any changes that are occurring there are going to eventually impact the GIS data model. And fields that they are actually creating in version 2 of CLDXF are shown here on the screen. There's a field for site. Think of site like a large campus area or a park. Subsite would be a smaller area within that larger site. So if we have a park, you might have individual tennis courts, basketball fields, baseball fields, soccer fields. Those are subsites. There's a new element called structure, and really it's the building field that's been repurposed. It expands on it, so it's not just a building, but it includes any other type of vertical structure. Then the unit field is actually going to be split out into two values. You can have a unit pretype and a unit value. And then they're adding wing, section, and row. When they implemented the NENA standards, there was very different examples that came up where they could not easily parse an address or a subaddress into the existing fields within a structure or site. It just wouldn't fit easily. And that's why some of these fields were actually created. The other thing that came up for these is that when folks were trying to implement landmark name and landmark name part, that was very confusing to folks. And it was also a subjective decision as to what a landmark was. In the GIS data model, there was actually 8 pages of text that tries to explain landmark and landmark name parts. And even with all that explanation, it was still confusing to folks. And many folks have locations that have names, but when are they considered landmarks? Locally, something may be considered a landmark. Someone 2 counties away may think not at all. So again, it's trying to remove some of that subjective decision making. So in the new updated standard that's coming, adding and redefining these fields is intended to help resolve some of these issues that were found during the implementation, or at a minimum, it's going to reduce some inconsistencies into how they were actually implemented in local data. So as noted on the previous slide, as I just mentioned, that landmark name and landmark name part was confusing to many. So what's going to happen is those are actually going to be removed from the NENA standard and replaced by the site, the subsite, and structure elements. And as I mentioned, building is going to be changed and modified and replaced by the new structure element. So items that you've had before as buildings will still be in there, but now we'll add other vertical features like cell towers or fuel tanks. And then lastly, you had that unit that was separated into the 2 different types of units. So you have your kind of unit, the type, and the pretype, such as an apartment or suite, and then the actual value that uniquely identifies that individual unit within a building, such as a number or a letter. Okay, parsing addresses. So I'm thinking at this point we might want to take a break and come back in about, I don't know, do you want to do 10 or 15 minutes? For my folks who are out there moderating.
Yeah, I think probably a 10-minute break would be appropriate, and then we'll get to the next piece.
Yep. So if everyone can come back within 10 minutes, we'll get going.
So I have 5 minutes after 10, so 10:15.
That sounds great.
All right, I'm going to share my screen here and run a little video, and we'll be back in 10 minutes.
Thank you. So are we ready to get restarted?
Yeah. Take it away, Cheryl. Everybody's
Alrighty.
ready. Here we go.
So hopefully we've got everyone back. Right at the end of the first section,
like
there
it,
was
yep.
some questions that were asked in the chat box. There was a question about how do we ask questions while I'm rambling on since I can't see all of you. Please drop notes or questions into the chat box. We have a couple folks who are monitoring it, and they will make sure that they will interrupt at an appropriate point and try to get me to respond to a question. Also, there was a question about the standards and best practices document. So that was actually sent out in a link from Jessica Jimenez a while ago. And Christine put a link in there to their page. And on that page, you can actually find the direct link to the document. So that's now in the chat box. Feel free to go ahead and look directly at the standard or download it.
Cheryl, we just actually have another question as well. It says, hi, I'm wondering why the NENA standard requires WGS 84 when the federal government is mandating the usage of GRS 80 for its new 2022 datums. This means NENA data will be out of sync with most county state GIS data in terms of geodetic data.
Okay, so that's a very good question, but you have to remember that NENA standards are not a US standard, they're an international standard, and they're being used across our borders in Canada, which will soon be going to NG9-1-1, and Mexico is also looking at extending it, and we're assuming it will continue to expand outwards from the US. And so it has to be interoperable with other 911 related systems across the world. And those also are using the WGS 84 standard. Now, once the federal government has some plans that are solidified and they actually come out with their 2022 standard, which everyone should know has been delayed. It's not coming out next year. It's been pushed back a couple more years. NENA is keeping an eye on that, and they will have guidance and recommendations on how to deal with that datum standard change at that point in time. Okay, are there other questions folks have that we want to touch on before we get into parsing? Okay, hearing none, if you're thinking of anything, go ahead and drop it in there. So normally when we do these types of sessions, we have the ability to be with you folks locally, and it's much easier to do this part when we're in the room. It's a very interactive piece. I know that it said, you know, stay on mute. If you guys want to come off mute for this one, that's fine. Otherwise, everyone should open up their chat box because we are going to try to do this parsing thing with your input. I don't want it to be just me telling you how it should be done. I want you guys to think a little bit about it and see if you can figure out how some of the parsing would actually be done. So first thing that we're going to do is we are going to talk about how NENA parses addresses into their fields. And the first thing to note is that this isn't something that NENA just came up with by themselves. There was already a federal address standard being developed, and it was published in 2011 by the Federal Geographic Data Committee. It took them about 10 or 11 years to create that standard. A lot of thought and effort went into that. And so the NENA fields were based upon what was created in the FGDC standard. So up at the top in blue, you'll see 4 fields that are blue. 3 of them are related to the address number. The address number prefix, which is anything that would occur before your numeric address number. And then the address number suffix, which is anything that would occur after that number. That would be your 1/2, your B, some of those oddball things. Now, when you're parsing an address number, I recommend that you identify the piece that's the actual number, and then the rest of the number pieces, the prefix and the suffix, easily fall into their components. Also in blue is milepost. So milepost can be used in place of or in addition to address numbers. That's just something to be aware of. A lot of times there are folks that will call 911 and they're standing in front of a mile marker of some type, and they may provide that to you. Now there are, unfortunately, twice as many street name fields to populate as there was in the legacy fields. Used to only have 4 fields. And with those particular fields, you have the standard one of street name, and you still have your pre-directional, your post-directional, and your post type, but there's 4 new fields that we're going to talk about. And when you parse a street name, just like the address number, my recommendation is start with your street name, and then you can work outwards towards the back and towards the front to populate the fields. So after the street name element is your post type and post directional, and then you have the new field called street name post modifier element. And this is basically anything that would occur in a street name that falls after the post type and the post directional. It's kind of your kitchen sink for the post field. Then before the street name, there's a whole bunch of new fields. You have your pre-directional, which you've used before in your legacy fields, but now there's 3 new elements. You have a street name pre-type, and what that is, it's basically a post type word that occurs before the street name. So this would be things like state route, highway, or even like avenue, if you have Avenue A, for example. Then there's another field called street name pre-type separator. And this is a rarely used field, but it's there for those occurrences where you have a pre-type that's then followed by some type of a prepositional phrase like the words of the, at the, in the, etc. And then the other new field is the street name pre-modifier. And that's for anything that occurs before the pre-directional and pre-type. Just like the post modifier, this is your kitchen sink for anything that occurs before the pre-type and the pre-directional fields that would go into that field. Pre-modifiers, post modifiers are very rarely used, as is the pre-type separator. So normally your addresses and street names that you have today, about 90% of them are going to parse exactly the same. There's going to be no modification. And then I would say maybe about 8%, they're going to use that new pre-type field, because right now you might be putting your Interstate 90 all in your street name field. Now you're going to have to put interstate into your pre-type field. Now the remaining 2% of your addresses, those are your oddball addresses that don't quite fit the normal 4 fields that you use in legacy. That now you have to split them out into a couple more fields. So you're going to have to use one of those 4 new fields, whether it be the pre-type separator or the pre-modifier, post-modifier fields. Now, there are many examples of these that we created. I think the folks that were in the GIS task force gave me about 120 or 130 different examples. And so we pulled a good chunk of them out and put them into the actual document to give you some examples of how to separate out a name and an address into these fields. There's even more detailed information and numerous examples if you want to go to the NENA CLDXF document. The Civic Location Data Exchange Format Standard is the one that talks about all those individual street name and address elements. So I encourage you to go ahead and download that document and have that available as a reference, in addition to the Wisconsin one, so that if you have a real question, you can go there. Okay, so hopefully everyone has their chat box up. We are going to move forward and we're going to start talking about how to parse examples. And we're going to start with the basics. So in this particular case, you have a number 38 and you have Broadway as the street name. So in road center lines, a street name is always required. And so if there's only one word, that's what's going to go into the street name field. And of course, address number is numeric. It can all go into the address number field. So we have 38 Broadway. Okay. Next example that we're going to look at is 142.5 Main Street. So in the chat box, where does the 142.5 go? How would we break that up? Or if someone wants to come off of mute and speak, please do so. I'm looking at the chat box. Anybody want to take a guess?
Everyone is afraid.
See, now normally I would be in the classroom and I would walk up to someone and I would just ask you. So I do a lot of NENA work groups.
Address number suffix.
Okay, 142 is the address number. That's correct. And then the half would go into the address number suffix. So if I go to the next screen, you can see how that's broken out. And Main Street should be very familiar to you. You have Main would go into street name and your post type is street. All right, so very common in Wisconsin are your local addressing grids. And so we have in the parsing and also in the best practices, we talk about your addressing grids. We have two different examples we're going to do in today's class. The first is one with a directional in the address number. So we have N2554. Where does the N go to? What field?
All right, we have an answer, prefix.
Peter says
prefix.
N is the number prefix, which means 2554 is your number. And so that's correct. You have that there. And then of course we have Johnson Street. Again, a very, very normal type of street name that you would parse into the street name field Johnson, and your post type is street. Notice everything is spelled out again. Okay, I feel like I'm doing a quiz game here. This is an example where you have a local addressing grid that has the locally defined grid cell address. So we have West 180, North 8085 Town Hall Road. So in Wisconsin, you typically have your two directionals, you have a number between them, and you have a number after them. So my first question to the group is, what is actually going to go into the address number field? Which number or numbers will go into there? Let's see how many people can guess it correctly. Besides Peter, because I bet you Peter's going to know what it is. Open up your chat box. We have one guess that nothing would go into the address number field. We have one that says 8085. We have one that has 180. We have another 8085. Anybody else want to take a guess? Okay, not seeing my chat screen go. Then we have a 180-8085. Let me show you how it's parsed. So my understanding of how the grid addresses work is it's based upon a grid that is west 180 and then north, and it's usually part of the number after it. However, the way that Wisconsin wants to do their grid reference, they assume that 8085 is your address number piece of it. And then this portion of it is your grid reference. So we put the numbers after the directional into your address number field, and everything before that then goes in your address number prefix. So does that make sense to folks?
And I think, Cheryl, we are trying to refine some of the language that NENA has in their documentation with the FGDC. We're working on that, but haven't heard anything back from them yet.
Okay, and if you don't hear anything in the next couple of weeks, let me know and I can check on that. So what Fred is talking about is if you actually go and you look at the NENA standard, which is based upon FGDC, they're almost telling you that part of this 80 is really part of your grid cell. So your grid cell might be west 180, north 80. And they're saying all of that, including the 80, should be in the address number prefix. However, in conversations that we had last year as we were working on the standard, it was pretty much considered by everybody in the Wisconsin team that that's really not how they parsed it in practicality. They put everything after the directional in the address number field. And so I've put them in touch with folks at FGDC at the federal level to talk about this and see if this kind of odd addressing exception, which only occurs in a few places in the country, which would be Wisconsin, Northern Illinois, and then there's one or two other small places that actually use an address number prefix, if they could modify how the grid representation is done within Wisconsin in their standards. So that may actually get solidified. But for folks here in Wisconsin, for consistency, this is how we would like folks to actually parse out an address number prefix when you have these two grid address number directionals in there. And again, this is in that standard. The link to the standards in the chat box. Make sure you go to it and download it so you have it locally, because when we get to the best practices, we have some really cool graphics we've pulled out. and we'll go over today too, that talks a little bit more about these addressing directionals. Are there any questions about this? And there's the rest of the Town Hall Road. That should be the easy part, right? Okay, so now we're going to go into another example. We have 2A East Main Street. What actually would be used for the A in the address number portion? Where does that A go? What field? Folks, open up the chat box. And everyone that I'm seeing so far is saying it's the address number suffix. That's correct. So you look for your first thing, what's the numeric, the number piece, and then you push out the rest of it, whether it falls before or after it. And if you're doing address numbering assignment, typically you don't want to use address number suffixes if you can help it. You want to give them their own unique number. And if you're talking about units, that should be something that goes into your subaddress fields. And then we have, as far as the rest of the street name, you have that pre-directional. Again, this is something that you're already doing in your legacy 911 type databases, so there's no change in that particular portion of your address. All right, here we have an example of 405 South Dakota Avenue. 405 is going to be your address number. But how would we parse out South Dakota Avenue? What's going to go into the street name field? So I need folks to respond either verbally or in the chat box. What goes into the street name field? We'll see who's paying attention. So we have a couple votes for South Dakota. A couple more. Okay, so you're correct. South Dakota goes into the street name field if you're referencing a place, which could be a geographic feature, a landmark, or some other similar feature. In that case, your directional is not put into the pre-directional field, but it's included into the street name field. And this is one of those things that requires some local knowledge as to whether the directional is going to be part of that street name, or if it's actually part of, because it's part of the place or the geographic feature or some other landmark or similar feature. Yeah, here's a real odd one. Here we have 32 West South 4th Street. So we'll start with the basics on this one. 32 address number, that's not a concern. What goes into the street name field? Again, we're starting with the street name. So we have 32 West South 4th Street. What is the street name? Open up your chat box, put in your ideas. We have a couple different options here. We have some that are saying 4th, some that are saying South 4th. Anyone else want to add in? Looks like most people are saying South 4th. Okay, for those who said 4th, you are correct. And that's because there is a rule that you would have two directional words occurring together before the street name. The second directional, if it's not the name of one of those geographic features or places or whatever, then what you do is you put the second directional in the pre-directional, and then whatever's left, which is the other directional, would go into the pre-modifier field. This is one of those weird occurrences. Remember that 2% I told you about? Hopefully you don't have many streets named like this or no streets named like this, but if you do get two pre-directionals that occur together before a street name, first determine are either of those pre-directionals relating to a geographic feature or place, like the South Dakota example. If not, then they have to be parsed out, the second one occurring in the pre-directional and the first one being pushed further out into the pre-modifier. And again, this isn't a NENA thing. This originally came from the Federal Geographic Data Committee. So if you download the National Address Standard from the FGDC site, you will see this example as well. Are there any questions about this one? there are, go ahead and drop them in the chat box at any time. Brian or Jessica will get back to me. Now, this is a fun one. This is an example that was brought up by our committee last year. And I actually grabbed a screen capture so that we could take a look at what's occurring here. But we have 109 West South Railroad Street. And what you have to understand is in the graphic, this Elroy Sparta State Trail used to be a railroad. Used to be some railroad tracks here. And a long time ago, when the railroad went through this municipality, there were roads built on both sides of it. There was a North Railroad Street. And then on the south side, there's both a West South Railroad Street and an East South Railroad Street that you can't see further off of here. So it's not just a North Railroad Street and a West Railroad Street. So the question to the group is, take a guess at what our street name should be in this case. We have two directionals occurring next to each other. We have a bunch of south railroads. We have some railroads. We have a geographic feature here we're referencing. And we have a couple different answers, kind of split on railroad versus South Railroad. So in this example, there's no railroad street, and the south directional is going to go into the street name field as it's referencing a feature. It's referencing the railroad tracks, and it's not a railroad street name it's referencing. However, the west directional will go into the pre-directional field because there's also an east to south railroad street. So this is two directionals. Again, you have to look at it from the perspective of, is this referencing some kind of geographic feature? And it was referencing the fact that there's a North Railroad and there was a South Railroad side. This is not straightforward. We are going to be doing some more of these seminars in a couple weeks, and we actually go into a couple more examples like this. Now we're going to get into our route systems. So here we have an example of 7843 County Road G. Based upon the stuff that I talked about at the very beginning of this session with parsing, what do you think the street name would be? So go ahead and open up your chat box. See how many folks, we have a lot of G's. And it looks like everyone thinks it should be G. And you're correct. The street name is G, and that's because we have that new PreType field where we have County Road now placed into the PreType field. We have another example. Here we have 8096 United States Highway 18 and 151. So the first thing that I'll note here is you're probably looking at and say, gee, can you do special characters in NextGen 911? And the answer is yes, you can. If you do have special characters, you know, something like this where you're talking about the two highways, you want to make sure that whatever you're using, you do it consistently throughout your jurisdiction. So if you're using the ampersand, all of them use the ampersand. Some folks we saw were using a slash, which is fine, but you have to make sure you use it on all of them. And then others converted it to the word and that might be because their CAD system can't deal with special characters, and that's fine too. So just as long as you're consistent, that's perfectly fine. But if you want to use the ampersand, it is perfectly acceptable. So in this particular example, what would be the street name? And while people are looking at that, Matt has a question about the South Dakota and not just being Dakota. And again, that's something that's a local knowledge. If it's not within your county, you might not have that local knowledge, which is why I pulled up with graphic to show that there was a geographic feature with the railroad. And in that particular jurisdiction where South Dakota Avenue was existing, without calling up the map, it wouldn't surprise me if they had other nearby streets that had other state names in there. So again, it's a local decision and knowledge as to what's actually being referenced. If that didn't answer your question, Matt, please let me know and I can try to pop on a little bit more. In the meantime, it looks like the notes that I'm seeing here in the chat box is folks are putting 18 and 151 into the street name field, and that's correct, which would mean the United States Highway would go into your PreType. And everyone's groaning because do I really have to spell out United States Highway? And the answer is yes, because this is for that machine-to-machine communication. What you have on your internal systems for your displays on your telecommunicators, they could be typing in USH and whatever the values are after it. And that's just something that is easily able to be done on your screen interface. But for the perspective of your next-gen 911 databases, having everything spelled out does remove all that confusion. Now we're going to have some fun. We have 10718 Old State Highway 21 Road. That is a mess. There's a lot of stuff going on here. So in this particular case, we're going to actually start and look at the number. That's easy. 10718, address number, check. What goes into the street name field? You have a lot of pieces to it. So we have Old State Highway 21 Road. What is the street name? And Jeff, I'll come back to your question after we finish this one, because my screen chat box is now displaying beyond it. So we have a bunch of folks saying Old State Highway. We have some saying State Highway 21 and others saying 21. Okay, so there's our address number. And what ends up happening is your street name, get my mouse back on the screen, is 21. You have your PreType, that's State Highway, and then your pre-modifier is old. And then of course, what falls after your street name is road. So there is a PreType that exists. Old is in there, it occurs before. Now, it is possible that you could have an occurrence where all of this would end up being in the street name field. However, in this particular example that was provided, they have your street name 21. They clearly know it is a state highway. It's just classified now as an old state highway, and therefore they've parsed it out using the PreType of state highway. It's not straightforward all the time because there are lots of opportunities for local knowledge to say, no, the way that this is set up, it's not a long old state highway. Maybe it's just now 2 blocks that are next to it. And it could be all parsed then into the street name element. But in most cases, and this is going to kind of go back to the question, I think that was asked a little bit ago about how critical is it to parse it exactly this way for finding the address. And it has been stated by folks that as long as you're consistent in how you do it, it should be able to find it. But most systems are going to be looking for something like this PreType to have state highway into the PreType field because that is a recognized element. It's very rare to have the pre-modifier field populated, but I also know that for a lot of folks going from 4 fields to 8 fields, it's a difficult thing to kind of swallow and do because you haven't done it in a long time. Or actually, you've never done it before. You've only had to do 4 fields up to this point. But the idea is to try to get some consistency on how it's being done. Now, there is a whole document in NENA about how location validation is done, and it looks at these different components, and that does play a little bit into what's being validated. But for the work that we're doing in breaking up addresses, again, when you get something like this, that's that 1 to 2% of your addresses that are really odd as to how they're being populated. In your legacy systems, you would just put it all in the street name, but if you can parse it out into these elements, it's recommended that it be parsed out that way. So in the pre-directional fields, it is the question that was asked before. What happens if you don't put them into the pre-modifier and into the pre-directional? How do you know that it's going to be able to find it? Personally, I don't know technically how it does that, but I do know that what ends up happening is when a system, your system has the street name in a particular way, it will look for that parsing first of how it expects it to be. And whether or not it can find it is one of those things that will come back and tell them, hey, here's how much of the street name I was able to match part for part. And so if it doesn't find it exactly the same, it will give them the next best option. And it might be the one and only option that's there. And it could be multiple options though. So the goal is trying to minimize how many different things are provided to telecommunicator. You want them to get to the exact place right away.
Cheryl, we have a question. We have a road named Old CC that was formerly County Highway CC. Would Old be the pre-modifier and CC be the street name?
So in that particular case, if you look at the current version of CLDXF, they have the definition for pre-modifier being one of two things. The first is you have to have a pre-directional or a PreType before you would have a pre-modifier. So if you just had a name that was Old CC, your street name would be CC, but you don't have a pre-directional or PreType, so Old would go into the street name. Now they have this alternative usage of pre-modifier that says, hey, if you need to create a list of street names, and in that list of street names, you want them to be alphabetized. So you're going to take out certain words like the or old so that your core street name would be alphabetized. That's an additional use of pre-modifier. So if you wanted to, for alphabetizing list, put old into your address, or excuse me, into your pre-modifier field under current CLDXF, you can do that. However, I mentioned CLDXF is changing. And actually there was a comment submitted about this during the public review about having multiple occurrences and usages for the pre-modifier field. And on our call last week, we actually had, I participated as a member on that work group. And on our call last week, we discussed this and we said, okay, how many people are actually creating lists? And it was kind of set up for, old paper lists or lists because you were comparing to your MSAG. In reality, people aren't doing that anymore. So we said, why are we continuing to carry this rule around with us that was originally created by FGDC when they started having their address discussions back in 2001? We're 20 years later. Do we still need to carry that? Are we just creating confusion? And so there was actually a vote last week that putting a pre-modifier in just to be able to alphabetize lists is no longer valid, that it's going to require a pre-directional or a PreType element to exist before you would use the pre-modifier. So it's even going to be a field used even less. So something like your example of Old CC, that will all go into your street name field. If you have something called the Cliffs as your street name, that will all go into the street name field. That won't go into the pre-modifier field anymore. Does that answer questions? Is that good, Mike? Yes, okay. So watch for that. I did mention NENA standards are changing, but you do usually have enough advance warning about some of these things. And the Wisconsin GIS Task Force, they're keeping an eye on these things. and they will make sure that as these new changes are coming along, if it will impact anything in the standard, they will be making sure that everyone else is educated about that as well, so that they can plan and prepare for an NG9-1-1 changes. Okay, now this example is a little bit different. We have Old Highway 70 Road, and this is very similar to what we talked about. However, in this case, my understanding, it was a very small section of road, and it used to be a highway many decades ago, no longer is. And locally, they don't consider it actually a highway anymore. It's just a street name. And because of that, they put everything into the street name element. So this is, again, one of those odd situations that does occur out there. If they wanted to, it would still be acceptable if they wanted to put highway into the pre-type, in which case your street name would be 70 and old would have to go into the pre-modifier field. And again, there is some flexibility in the standard that does allow them to do a little bit slightly different parsing. And this is Brian's favorite example. We have North 7105 Path the Bear. So let's start with the address number. We haven't played with address numbers anymore. Where does the N go? Which field? Open up your chat box. We have a couple prefixes coming in. And yes, the N is occurring before your address number, so the entire address number is 7105. Now, what about Path of the Bear? What is going to go into the street name element? Again, just the street name we're looking at. And we'll see how many people are waiting for someone else to type before they put stuff in. So looking at Path of the Bear. We had some that start out with bear. We have some that are saying Path of the Bear. Need some more votes. Okay, so we started with bear, now we have a bunch of Path of the Bears. So for Jared or Rachel or Jeff or Joe, why did you just say bear? Can you put in the chat box why, or come off of mute and say why you think it's just bear? So we have a couple about the separator element, and then we have the pre-type. And that's correct. It's actually Path of the Bear because path is a post type as well as a pre-type. And so if you have something with a pre-type value, that would go into the pre-type field. And then of course your prepositional phrase goes into the separator element. So when you're looking at words that have prepositional phrases, don't automatically assume that they would go into the separator element. You have to look at the word that would occur in the pre-type field. So if we have, oh no, this is Brian's favorite, Chicken in the Woods Road. So I don't know if anyone's been in Chicken in the Woods Road, but we would have address number 123. What's going to be our street name in this example? Folks, open up the chat box, make your votes. We have a couple woods, we have a couple, the full thing goes into there. Kind of getting going back and forth, back and forth, back and forth. And the answer is it all goes into the street name. There is no street name post type called chicken, at least not in the US Postal Service, not in the NENA registry that exists in there. And because chicken is not a post type or pre-type, therefore everything would go into the street name element. So don't get confused just because there's the prepositional phrase in there. Look at what occurs before it and say, would that be in US Pub 28 if I went and looked it up? And if you're not sure, go pull US Pub 28, or better yet, look in the NENA registry that has all the street name pre-types and post types listed. and it's actually available online to look at it. Is there any question about the chicken in the wood roads example? And Brian wants to do a field check on that street name someday. So if someone wants to take him, let him know. The next example is pretty straightforward. Now we're going to start looking at all the elements that occur after the street name. So we have 934 Azure Court South. And I think you're probably used to parsing this already with the same way you do in Legacy. So you have your number, your street name's Azure, your post type is court, and then you have a post directional. Well, what do you do when you have something like this? 4718 West Washington Avenue, frontage road. Okay, so let's start with the basics. We know where your address number goes. What's the core street name? Always start with your street name element and work outwards. Okay, we have a bunch of Washington showing up. That's correct. And then of course we have west being a pre-directional. And then what happens with avenue and frontage road? Let's start with what is going to go into the, or let's do it this way. Where would frontage road go? You have three options after the street name. You have post type, post directional, and post modifier. And there's no directional in here, so we all know that that's not an option. Would it all go into the post type, or do you split it up? Okay, so we have a couple that are in modifier, some for post type, and they're either is a possibility as to whether you put it in the post type or you put it in the post modifier. But there's a reasoning. And the way it's supposed to go is frontage road is not an actual post type. If you look at the list, it's not currently in there. Therefore, it would go into the post modifier. Now, if you look at the FGDC standard and the NENA standard, there are occasions when you might have avenue extension, in which case you have two occurrences of a post type, and therefore they would both go into the post type field. In this case, because frontage road is not one of those post types, the only place it can go is into the post modifier field. Another one that would confuse people would see like Washington Avenue extended, ending in ED. Extension, ION is a post type, but ED, extended, is not. So you might see Washington Avenue extension and have Avenue extension in the post type. But if you had Washington Avenue extended, your post type would be Avenue, and extended would have to be placed in the post modifier. So again, for the pre-types and the post types, look at what the domain values allow, and that will help determine how to parse a street name out. And again, the usage of the pre-modifier fields and the post-modifier fields is pretty rare. It doesn't occur a whole lot. And I believe this might be the last example we have for today. And this is United States Highway 151 southbound. So in this particular case, we've already done some parsing out of route numbers and names. So we would use the pre-type for United States Highway. 151 is definitely in the street name, but what is the southbound? Where would that particular piece of the element go? Would it be included as part of the street name, or would it go into another field after the street name? So I'm seeing some that are saying modifiers, some saying the post directional. Some more opinions in the chat box. You have some more that are post directionals. Okay, so the answer is it goes into the post modifier field. So two things to note. First, the post directional value has only 8 allowable values in it in the US language. That's north, south, east, west, northeast, northwest, southeast, southwest. There's no southbounds, northbounds, eastbounds, westbounds as a directional. The southbound is actually a traveling direction, and it's used for divided roads. And it's typically not part of an official 911 street name because it's just talking about a directional, but it's very, very useful in divided roads, particularly those that have full control of access, so the responders know which entrance ramps to use in order to get to the incident that they're responding to. You'll note also that in this case, we have the post modifier in lowercase. When CLDXF version 1 was originally being created, there was a state trooper in one of the states who asked that, is there a way to add these traveling directions in here? Because they sometimes had 8 to 10 miles between exits. And of course they had their turnarounds, but they were still 2 miles apart. And knowing which the traveling direction was of an incident was critical. So there was a lot of discussion in CLDXF. And it was agreed that this is the one and only case that when you're parsing out a street name, you can include a word that is not a part of the official 911 street name. And it would have to go into the post modifier field, and it would have to be in lowercase to help signify that it's not part of the official street name. Okay, so we have a question from Jeff, and we would use Highway 151. At some point, we can talk about how folks plan to maintain both data, local use and NG9-1-1 multiple fields. Okay, so one of the things that is important to note about the new standard, again, it's based upon FGDC, and it breaks an address out into its smallest components. And by doing that, you're actually able to put data back together whatever way is needed through an ETL process for usage in CAD systems or other systems. So from the perspective of how do I maintain my data, one of the reasons that we also put in the 2 WILA fields for the full street name and then the abbreviated full street name was so that you would have the option of keeping the street name totally together. So if your system would benefit from that, it's already in there. Those aren't necessarily required for NG9-1-1, but in most cases, especially for map display, it makes usage of those fields much easier if it's all together in one. Again, if you have the capability to write little scripts to do ETLing, that's definitely one of those situations that if you have it already broken out into its smallest components, it's quick and easy to just run it through the program that knows how to put those fields back together. But in most cases, as we've seen, 90% of your street names are exactly as they already are in your database now. It's your highway numbers, I know, that are a little bit different. And you talked about the abbreviation field. So maybe that abbreviation is what's actually in one of those 2 WILA fields. Would you agree with that, Jeff, that it would be covered in that abbreviated field?
I guess if he could provide a little bit more information why he says there's 100 fields related to a street name or address point.
Jeff, can you come off mute and give us some more background, please?
Can you hear me now? Sorry.
Yes, we can. Yep.
Okay. No, I just mean, like, given our other, needs within the county, if you look at the number of attribute columns that are in our address point layer and the number of columns, attribute columns in our street center lines, I mean, there are, I'm not going to say there's 100, but we're getting close, maybe 50, something like that. So I guess I need to look into the ETL a little bit more. But what I was thinking is, or what I was wondering is if others are adding new columns that are specific to NG9-1-1 and then basically duplicating. So in our case, we wouldn't use PreType United States Highway. We might use USH, for example, as an abbreviation. and those sorts of things. So I guess the ETL thing might handle it, but I thought maybe there are others who are maintaining these NG9-1-1 fields separate, sort of in addition to what they use for their local needs. Does that make sense?
Yes, and definitely the ETL would be able to go through and look at your, as long as you have your PreType field, if you had in there USH 151, it can look for those USH values and convert them to United States Highway when it exports the data for NG9-1-1 use. And again, it's a local decision right now. I know the ETL processing we've talked about last year when we were developing the document and how it could be useful. But for those out there who are maintaining data from multiple purposes, including 911, do you want to pipe in and talk a little bit about what you're doing? Do you have a volunteer?
One other thing, we just implemented a new 911 system here in November. And, given those guidelines, there are other things like we would have actually put USH 151 all in the street name field. And instead of using PreType, maybe it would work the other way, but I guess when we worked with the vendor, there were certain things like that are a little different than what I'm seeing here.
Yep. When we get into the best practices, you're going to keep hearing me say over and over, talk to your CAD vendor because they're not there yet. Some of them have started adding some of the NENA fields, but not all of them have them there. And then also from the legacy transitional phases too, there's probably going to be issues with that. So one of the key things that you have to constantly do is understand the limitations of your current software and then what you also need for your next gen 911 system. And that's going to be really important to be working with the next gen core services provider. They have to be aware of what your limitations are on the back end and what needs to be done on the front end for call routing, because call routing occurs before it gets to your telecommunicator, whereas your CAD system are looking at what happens once the telecommunicator receives the call. Then what do you do on the back end?
Cheryl, this is Andy. Don't you think that the CAD vendors in the future are going to have to follow the NENA standard, or they're just going to die off?
Yes, they have to. And several of them are going through the process of adding fields into it. I know when I was working in the state of New York and we were building out our statewide file of address points and we were using the new standard, we were constantly beating up on them and saying, you guys got to get with the program and start adding these fields in. We'd be happy to work with you to explain how they're using. And several of the CAD vendors have started doing that. It was easy for them to add things like the PreType and the separator elements. The modifiers, they're not used as much. They're a little more confusing. But we actually now have some of the CAD vendors are starting to participate in the NENA standards. And it's more of a timing thing. They have all this software that's built on the back end and lots of customers using it. And they're probably in multiple versions. So they have to continue to work on migrating individual customers to newer versions. And so there's definitely a time lag in there, but it is worth having that conversation with them to say, hey, if I maintain data in this way, maybe they can do the ETL for you in order to be able to use it within the CAD system. And I know some of the CAD vendors are doing that as well.
Cheryl, this is Fred. Just to Jeff, I think the key point here is that when you're maintaining the data, the intent, whether it be the NENA standard or even the WLIA standards, is that it's kind of a uniform kind of structure. And if you have to publish to the use for 911 into their specific CAD, you can easily do that as through a publishing or an ETL process, but that you don't maintain it in that silo structure. Rather, you have it kind of as a common data set that can be used to publish any way we want it, whether it's abbreviations or not. Perhaps we can talk more about this after this, or even at the special interest group meeting on Wednesday afternoon. So that's really the intent here, is that you have a uniform structure, because ultimately it's not just 911 that needs to have addressing. It's going to be a number of other county departments that have their own kind of structure that they want to see things in. And you can't be maintaining all of those variable flavors. You should be able to have one kind of vanilla that you can then add some chocolate or add some strawberries and make it specific for a certain application.
No, and that's exactly what I'm after. And that's what I thought what we did last year is
Yes.
get to where we were to the greatest and best standard that we could possibly be at. It's just that what I'm seeing here, this looks a little different than, say, what the CAD vendor needs, what the WLAA statewide parcel standards are. I'm seeing differences, and I'm just trying to figure out how to reconcile that. Now, I'm not very familiar with ETL scripts or what might be available for that sort of thing, but I'll have to look into that some more.
Yeah, and we can have more further discussions. I mean, this is something that beyond today's workshop, we should be as a group, and something that Andy Faust and I have been talking about is having more maybe strategic or special interest group meetings to delve into specific items and have a better conversation about that.
I would think as ETL scripts start to be developed, that the state will, or maybe it's the WLAA group, creates a library of them to share them with the others. So if somebody is using a particular software or needs it in a certain format, why should you all be creating the same ETL script? If somebody creates it, kind of have a share site where you can take advantage of each other's technical expertise. All right, anything else before we move on to talk about best practices, which is the last portion of our discussion today? Okay, so I'm actually going to turn this over to Jessica. She has been involved in the QC, and so she has the knowledge of this. Jessica?
Hey, sorry, I had to get myself off of mute and get myself back on camera. So, okay, so I believe probably the large majority of you all were a part of the county calls that we had. If not, please find someone in your county who was on that call. They did receive all of the results. And so basically for the quality control checks, we're really talking about those checks that we did for NextGen 9-1-1 as a part of that process. So most of these are going to look super familiar to what you have already seen in those calls. The first one here with the general QC checks, really what we're looking for is, are the mandatory fields present? Are they populated? And do you have unique IDs? And not just unique, but NextGen 9-1-1 unique IDs. One of the things that we did as a part of the project for quality control was to add a unique ID if it was not already present. And that really just was for your benefit when you were looking at the results. For those counties that didn't have NG UIDs, we did provide that information that here is how you should do this moving forward. For the boundaries, we looked for gaps and overlaps. Keep in mind, not only do we look for those in the individual boundary layers, but we're also looking at them for how the emergency service boundaries cover the provisioning boundary. And don't forget, the PSAP boundary is an emergency service boundary, so it is included in there. And as Cheryl mentioned, the provisioning boundary is just really that authoritative. This is your specific area to provision into the system. For the site structure address points, we looked at several different checks. Mainly the addresses are unique and that the addresses were completely within your provisioning boundary. Now, I know that there are circumstances where maybe an address or two is part of another surrounding county's PSAP area just because that's the way the 911 call routing occurs. There may be no way to get to it from the county in which the structure is involved in. And so we did talk about how, to deal with those items. And again, Cheryl did mention that we're going to have some additional sessions, so we'll talk about that a little bit more in a couple of minutes, plus on those additional sessions. So Cheryl, if you would go to the next slide, please. For the road center lines, we looked at four really kind of primary areas. The first two here deal with the segments. The first one is that they are broken at the boundaries and stacked to features. Now, keep in mind that we're really kind of talking about breaking it at boundaries where mandatory attribution changes occur. So we're not looking at all of the boundaries. In E911, we typically look at fire, law, and EMS. That may or may not be the case in Next Generation 911 or for your CAD systems locally. The next one is the segment length, and is it drawn in the correct direction? So we know that there are super long segments in some jurisdictions and super short segments in others. It really depends on how you break your segments at the boundaries, and at specifically if you have teeny tiny short segments, those kind of can throw off the systems. Then we also look at the ranging. Are there gaps in the ranges? Are there overlaps in the ranges, which overlaps are very important to resolve. Gaps, not quite so much, because we do know that there are jurisdictions that have potential or theoretical ranging, where gaps may not be present, but then you also have counties or jurisdictions where it is actual. So you do have the potential to have gaps in your ranging. We also look at directionality of not just the segment drawn direction, but also does it match the directionality of the ranging, and then parity issues. And when we were talking about the new fields for Next Gen 911, one of the fields that was rarely present in the local data was the parity left and right on the road center lines. This, of course, is an important couple of fields in your Next Gen 911 data, and the details about those were presented in each local call, plus in the standards and best practices document. So you'll definitely want to check those out if you're not familiar with parity. And then the final one for the road center lines is that the segments are all within the provisioning boundary, or that none of them lie outside of the provisioning boundary. Again, we do know that there are circumstances where segments may be in a local jurisdiction's data set because you are the primary PSAP. And of course, as you transition to Next Gen 911, you'll want to make sure that you are handling those with your neighbors. The next one on the slide here is the address points to road center lines. Now, this is mainly to ensure that the synchronization between the two is good. With that being said, Cheryl mentioned way earlier in the workshop that there are situations where address points exist with no matching road center line. And we know that those occur, but for the large majority of structures, there are a matching road segment. And really what we're looking for here is it really the correct road name? Is there no misspellings? Is it on the right block? All of those kind of issues. And of course, you know, we always have the odd even issue on the wrong side of the block. And when we get down into a couple of additional slides, we'll talk about exception codes. Next slide, Cheryl. We also do some additional synchronization. So we looked at the alley or the telephone number listing to the road center lines. And what our goal here is just to really make sure that every existing wireline phone in a jurisdiction can be matched to the road center line. We also check the alley to site structure address point. Now, this is really important for jurisdictions who are more point-based, because there are a few Wisconsin counties that are primarily point-based and not road center line based. And so that is a vital check for them. And of course, we all know that site structure address points are much more locationally accurate than the road center lines are oftentimes, depending on how far the structure is from the roads. And then the MSAG low and high to the road center lines. Now, this is not something that as we transition to Next Gen 911 is really deemed an overly important synchronization, but really what you kind of uncover here with the MSAG or Master Street Address Guide to Road Centerline Synchronization is what are some of those gotchas in the legacy fields, and really helps you then populate the 4 legacy road centerline fields for that MSAG conversion service that is a part of the Next Gen network. And as I recall, somebody put in the chat just a little bit ago, on Washington Street, it is Washington Street, but if you have a specific provider in Wisconsin, they've decided that that needs to be trimmed down to 4 characters. So in their case, their legacy field is Wash and not Washington. So it kind of really uncovers all of those big ticket items between the legacy databases and the Next Gen 911 data layers. Now, a couple of additional things. The next to the last bullet, we really often find that jurisdictions are asked to be 98% match rate. And this is not like 98% overall for your GIS data, although we did provide some accuracy and some increases if you do certain things during the calls and the reports. But really, this is looking at the alley to road centerline synchronization, because what we don't want to do is we don't want to alienate any telephone numbers that are able to get 911 service to be default routed in a next-gen environment. So really, typically it's 98% for the alley to road center lines. And then the last thing here is just to talk about quality control exceptions. And these are known errors that there is nothing that you or I can do. They exist in the real world. It's like that odd address on the even side of the road. It's been there for 20 plus years. Nobody wants to change it. Perhaps maybe the mayor lives there or somebody who does not really want their address changed, and you can't do anything about it. So you will have in the future, once the core service solution has been set up and the process has been evolved, you will have these feature level exceptions that you can write. And I see that there is a message in the chat. Are there any QC tools available to us that will report out how well our structure address points match the road center line ranges? Yeah, so Jeff, I'm not sure which county you're from, but we did do quality control on all but 2 of the counties in Wisconsin. They had just recently gone through a quality control process with their provider locally, so we didn't do those 2. We did do those checks for all of the counties. So if you would like to send me an email afterwards, if you didn't receive those results, I'd be happy to provide those to you. Now, one thing that you will want to do if you're able to is on our Wednesday afternoon session, when Jessica Jimenez is able to join us, she will talk about what is the Next Gen 911 process and project looking forward into the future in Wisconsin. And they are looking for a GIS managed service or something that you all can continually have your data quality control checked into the future and as you transition to Next Gen 911, and then once you are also transitioned there. So more to come on that. But again, if anybody didn't get their results, if you need your results, if you don't have it, please feel free to reach out to me. And I believe, Cheryl, unless I am incorrect, our email addresses will be on the slide at the end. If not, we can put them in the chat.
That's correct. They are on the slide at the end. So when we get to the last slide, we'll leave it up so folks can grab it at that time.
Thank you, Cheryl. Now I'm going to turn it back over to you.
Okay, thank you. So the rest of our session today for the next about 35, 40 minutes is we're going to touch on best practices. And these are all in the Wisconsin GIS Data Standard document that we've been talking about. So we've pulled out a lot of them. We're going to touch on them briefly. And the thing to note when we created these is that we work with the Wisconsin DMA and the WLA GIS Task Force, and we facilitated discussions that led to the development of these best practices. These are not hard and fast rules, but they're just simply guidance, and they're provided to help have the data be a little bit more consistent across the state. And we also focused on some kind of the oddball situations that you're going to run into. And folks were like, what do I do in this situation? And so we did a lot of talking through what would be a best practice in these particular cases. And that's what we're going to touch on today. So just from kind of the high level general things, there are fields in the data model that are not required. You don't have to put everything in there and start populating all the fields. You're going to want to focus on those mandatory fields first, but then have some kind of a strategy for how you're going to address and populate those optional fields. And that really leads to making sure that you have a really good data development and maintenance plan early in the process. That's going to make sure that you use the best you use your resources, which are very limited. You know, your time is important too, so you want to put it to the best use. Another thing to note, and everyone's going to roll their eyes when I say metadata, and we all hate doing metadata. So you're going to need at least some basic information so that when you're sharing your data with others, that recipient clearly knows what's coming over with that data. And if they do have questions, who they can contact to ask more information about it. Another general consideration is folks have access to high resolution orthoimagery, and there's a great local program within Wisconsin that is creating orthoimagery. But do you wait until you have orthoimagery, or do you go out and do GPS data collection? And the kind of thing to look at is if you have imagery in-house that have the features that you need to capture, that's going to be way more cost effective for creating data or updating data than actually sending your resources out into the field. So always be looking at that from a cost perspective of your time, having a value as well. So I'm going to delve into our road center lines best practices and our site structures and the other required layers. So with road center lines, the accuracy of your boundary data is really important because you're going to be aligning your road center lines at that boundary with your neighboring jurisdictions. And if you have a road center line that crosses that boundary, you want to make sure that you're both snapping to the exact same point. So you're going to need to work with your adjacent counties. And sometimes that means if you're a county that occurs on a state line with those neighboring states, to make sure your features align at that boundary. And again, this is, I remember I mentioned before, I'm going to say a lot of times, limitations of your CAD software. A lot of CAD software is not yet 911 compliant, and they're going to have requirements that might not be in alignment with these best practices or even the data model. So in the site structure address points, there are 5 different placement methods, and some of these methods require more time and effort to place than others. So if you have no address points at all and you have to start somewhere, consider the level of detail that you need. Can you start out with just parcel centroids and then over time move them onto structures? Or perhaps if you now have address points, do I really need to go down into the level of getting to a subaddress? Well, maybe you only deal with the subaddresses that identify individual structures. So you might have a site where every building has the same address number, but their individual building numbers differentiate them. So you might go to that particular level. And just like road center lines, you have to understand your limitations of your CAD software because some CAD software may not even recognize subaddress fields or be able to differentiate between those different placement types, whether or not you have a structure point and a property access point, for example. And then with the PSAP, the ESB, and provisioning boundaries, it's really critical that you have no unintentional gaps and overlaps. And note also that these often are not identical to your legal boundaries. They may not be the same as your county boundary, your city boundary, or your village boundary. You need to have a boundary that everyone on both sides of it agrees reflects those areas of responsibility. So work with your adjacent entities and your states to make sure that those boundaries are agreed upon, and that will help avoid any unintentional gaps or overlaps. And again, these are just best practices, our recommendations. They're not the requirements. Okay, so let's start digging into some more specifics of the road centerline best practices. We have a whole section in the document with that. So looking at digitizing directions, kind of straightforward, but you want to make sure that your road center lines digitized in the same direction that your addresses are increasing, Or if you don't have addresses, increasing mile markers. And when all else fails, if you have a local addressing grid, use that and digitize in the direction that it increases. A lot of times you have roads that have some kind of a physical barrier, so you're going to need to have two different center lines. Now, a barrier is not yellow painted striping or a flat surface that an emergency responder could drive over without, those are things that are not considered requirements for having two center lines. And then one of the conversations that we had in our group last year is we started talking about cul-de-sacs and whether or not you need to show that little median at the end of a cul-de-sac. And one of the people brought up a very important note was that a lot of times your fire responders for planning purposes, they need to know the limitations of turning a large vehicle around in the cul-de-sac. So it's pretty much a best practice that if you have a physical median in the center of a cul-de-sac, that you should probably show it. As far as segmentation, we identified many cases when you want to make sure that your road center lines are split. So if you have a road crossing another road and it's truly an at-grade crossing, you want to have it broken there. You also want to have it broken at your boundaries. So your counties, your PSAPs, emergency service boundaries, MSEG, etc. And also if you're maintaining some of those other optional boundaries in your data, such as the unincorporated community, your neighborhood community, or even your postal boundaries, you need to make sure you show those breaks. Basically, that means anytime an attribute value in your road center line changes, you can't show that change unless you break your road center line and split it. There are also some other optional attributes that would change, and if you're carrying them, those would be like your one way, your speed limit in road class. But that's only if you're maintaining those values in your file. You might have the fields in there, but if they're not populated, you don't have to worry about breaking them for those occurrences at this point in time. And then what do you do if you have an intersection at an overpass or underpass? Well, if the software includes any type of elevation attribute, such as a z-value, the best practice is not to split the roads at the underpasses and overpasses because your software can deal with that. And again, it's going to be dependent upon your CAD software, so talk to them. Also talk to your core service provider to understand those limitations. And we had talked during parsing about addressing grids. So here we have some examples. And again, these are in the document that we talked about having local addressing grids that require some segmentation when that address number prefix. And that occurs not always at an intersection. So for example, in the left image, you can see that the address number prefix is going to change from 184 north to West 185 north when you're traveling west into the next grid block. So you actually have to break the road center line in order to be able to show that change in the address number prefix. Now in the right example, in this system, we have a local grid system. It doesn't include any of the directionals, but it's still a local grid system. The road that is shown on the screen, it's all the same road name. It's North Breezeland Road. But you'll notice when the grid addressing changes, there are much different address number ranges. You have numbers that are in the thousands that go into the 34,000s. So in this case, we have to show segmentation where the road changes direction due to that large gap in address ranges. And here's an instance where you would have an intentional gap in your address ranges. You wouldn't pad those ranges because if you pad the ranges, you're going to end up having any of the address values associated with that range be pushed too far to one edge or the other. So we talked briefly about boundaries earlier, but you also want to make sure how things align at the boundaries. So it's very important that when you have roads that cross the boundaries and they're segmented, that they're broken there. And what that does is it makes sure that the address number that can occur up to that boundary is going to be shown in the correct boundary if it has to be used for any type of location where it's being geocoded. If it's off just a little bit in your address range, you will be very potentially putting a call into the wrong boundary, into the wrong PSAP. Therefore, you want to make sure your road center lines are snapped at the boundaries. And if you have a road, like a county line road that falls along a boundary, that it aligns node for node with that corresponding boundary. And again, you're making sure that you don't have any spatial gaps or overlaps. Now, when you have your boundaries, you really need to be talking with your jurisdictional neighbors on the other side, because you have to be in agreement on where you're going to show the boundary. One of the ways for data maintenance purposes that has proven successful by several folks is creating what we call a stitch point layer. And what that is, it's an agreed upon location of points where GIS data from one jurisdiction will end and the GIS data for the adjacent jurisdiction will start. So think of the example of road center lines that cross over a county boundary. If you create points in a stitch point layer where the road would cross the boundary and each jurisdiction on each side snaps to that point, then you have no gaps or overlaps in your road center lines from a geospatial perspective. So it's very good to make sure that you have to have those agreements in place to understand how your data is going to be built and avoid those spatial gaps and overlaps. So here's an example where sometimes we have a PSAP boundary that doesn't necessarily align to the county boundary due to agreed upon response areas. So on the image on the left, you can see it's an overview where we have a little peninsula. County line goes straight through it. There's 3 addresses in the county to the north, Vilas County, and then there's a county to the south of it. So even if the 3 addresses in Vilas County were considered within the Forest County PSAP boundary, that road, that Han Road, still must be split at the county boundary, and that's to accommodate the area name elements that change. The county, the incorporated municipality, if there's incorporated municipalities, and also the change in the local addressing grid for the address ranges. Notice in Forest County, they're in the 16,000 range, yet up in Vilas County, they're in the 2,800 range. So both counties, they're going to need to agree on the location of the GIS representation of where that boundary is going to be and the point on the boundary where they will both snap their RCLs. And that would be their stitch point.
Cheryl, we have a question.
Yep.
Do the successful implementations of stitch points use the same datum and projection?
Because of data transformation, you have to have an agreement that if you create a stitch point, what is the projection going to be used? So if you're maintaining locally your data in a different one, you have to be able to transform your data, or at least have the stitch points in both locations, both datums that are exactly one-to-one match. So you might create a stitch point layer and put it in one datum, and your adjacent one uses different datum. You use the exact same stitch point layer, but you transform it to the other datum. Again, if you're doing transformations, make sure you're working with someone who's very familiar with transformations and the potential issues that could occur, because it's very easy for very minor gaps and overlaps to be created. You want to, think about precision as well and how far down into decimal point layers you need to go to make sure that you're truly maintaining things the same. Any more, Brian?
Yep, we just had another one as well. How do you handle a road with a different address grid on each side of the road? We have a solution which works for with our current 911 vendor. Not sure if it will work for NG9-1-1.
So if you're talking about, can you have address range gaps? What, I'm not exactly sure what's being asked.
So that question is coming from Adam Dorn, if he's available.
Yeah. So in the instance where you have a road center line that matches a municipal boundary, and the 2 municipalities in each side have different addressing grids, you may have a left side of a road that has a range from 100 to 200, and then on the right side, it's a range from 1,000 to 2,000.
Okay, so the good news is on road center lines, there is a right side address range and there's a left side address range. So you'll be able to show your address range as it exists on that side. You don't have to duplicate segments at all. In the best practices document, there's also what do you do if you have different street names on each side in that case. And the first best practices, get together, sit down and figure out which of you should change your name of the side of the street, because you shouldn't be doing that anyways. But if you're really stuck with that, then in that particular case, you may need to do something like having two parallel road segments where you have one road segment that's for one jurisdiction, where they populate the side that faces their jurisdiction with their values and the inside is not populated at all. And then you have very close to it the parallel segment for the other jurisdiction, because they have the different street name, and the outside is populated with all their values, their address ranges, and their place names, but the inside is not populated at all. It's kind of messy, and it's not a good situation, but we know folks have inherited a lot of these poor addressing things, and they're just trying to figure out, how do I make it work today?
The
Yeah,
other thing
that's,
to point out, Cheryl, too, and Adam, is that you have to decide on what is the direction of your line,
Yeah.
and then pick which address range follows the proper low to high. And then if your other side is in a reverse order, you may have to adjust your numbers from on your high and your low.
currently we're doing the duplicate road center lines, and we have some of those situations on county boundaries. So it's good to know that we can work with that solution and refine it over time.
Yeah, with the digitizing direction, it's great that today the software programs can deal with it. If you have, lower numbers in the two addresses and your higher numbers in the from, it doesn't freak out. Unlike, 25, 30 years ago, we were really struggling with some of that stuff.
The good old days.
I'm dating myself. Anything else in the chat box, Brian? Are we good?
Sorry, just getting off mute. No, I think that's, we're ready to move on.
Okay, so then we'll move forward and talk briefly about address ranges. Again, we've seen some examples where there are intentional gaps or overlaps, but you really want to make sure you don't have any unintentional gaps or overlaps. We saw the ones that exist at some jurisdictional boundaries. In our discussions last year, we had some conversations about, well, do you use potential ranges, or do you use actual address ranges? Where it's, what's the real high number that exists here, and what's the real low number that exists here, and we shouldn't have the ranges before them? Or do we show the padded ones where, we have an addressing system that was laid out every 52.8 feet as a theoretical address, so why don't we show them? Well, there's no NENA requirement regarding which ones to use, and there are pros and cons for both of them. But it's important to note that with your potential address ranges, those require much less maintenance, because anytime a new structure is added that might be beyond that last number, now you have to go in and change your address range again. And as far as 0-0 address ranges, typically you want to avoid them, as they're going to conflict with your QC processes. But on a rare occasion, you might have an address range actually start with a 0, because you might have a first assigned address range where they didn't leave any number for growth, and somebody went and stuck a new structure in, or maybe it was a back of a garage that got addressed, and now you have address number 1/2 or 3/4. Yes, there is addresses out there with 3/4. But again, confirm with your CAD software, because there are some CAD systems that do require 0-0 ranges. In your naming and addressing, we talked a little bit about this in parsing, but I just want to reiterate that when you have travel direction, you can include it, but that goes into your post modifier field in lowercase. And in our discussions, we also got into a big discussion about, what do we do with ramps and interchanges, those roads that come on and off? A lot of local DOTs have rules. Some of them are just using plain ramps, some just use exit number. And so there is no national, this is how you should do it. However, there were a lot of state DOTs who had some ideas. And the key thing that we focused on was try to provide enough information so that you're describing which of those ramps, especially if you have a cloverleaf interchange, that a person is actually on. So the structure that we came up with shows that if you have a ramp or exit number, it would start with that. And then you would have the from street, the direction that you're traveling, if it's a divided road, the word to, and then what street are you going to, and if that was a divided one, which travel direction. Now, the one thing to note at this point in time, we're putting everything into the street name field, but that only has 60 character limitation. And because of that, we said, okay, not everything's going to fit if we say spell it out. So as you can see on screen here, we chose road jurisdictions and travel directions and came up with some shortcuts and abbreviations to use for them. And then on screen, here's a couple of examples. So here you have an off-ramp, and it's exit 87 on I-39 traveling northbound to State Highway 33. And so it just says State Highway 33 because it exits off, and when you get to the end of the exit, you can go either direction. The second example is you have an off-ramp on S54 westbound to Bay Settlement Road. And then those are off-ramps, but you could also have an on-ramp from a local road, West Silver Spring Drive, and it was a divided road, so you're traveling eastbound, and you're going to I-43 southbound. So there are some examples that are pulled from the best practices document. Again, they're just guidance. You don't have to do it this way. But if you only have a generic ramp right now and you're looking to potentially add more information, this is a recommendation that you could potentially investigate and see about using. So what do you do about overlapping routes and when you have multiple street names? So it's not uncommon that a road can be known by many different names or route numbers. You can have Main Street in a city, and overlapping it runs a US route as well as a state route. In NextGen 911, the most important thing to note is you should be putting the official 911 name assigned by the street naming authority on your road center line. Now, all the other names, those are considered alias or alternate names. And so somebody traveling out on that road may not recognize what the real local name is. They may not realize they're on Main Street, but they see that they're on US Highway 62. So they may call in and they may be talking about they're on US Highway 62. NENA has a street name alias table as a strongly recommended layer. We talked about this within the group last year, and at some point in the future, they will be looking at some of these other strongly recommended layers. And so they will eventually have an alias table structure that will allow for multiple names. Now, if your CAD system lets you do this now, that's a great thing. You should go ahead and be working on populating that. I want to show you some examples about what do you do if you have a road where you have two official street names overlap, such as a roundabout or traffic circles. We know roundabouts are becoming quite popular out there. So we have this stated hierarchy that you would have with your interstate name, and you go down to your other local memorial or street name. So in a traffic circle, what you would want to do is look at an area, if you have a segment where your north route, north-south route, and your east-west route cross, and they're both going through this circle. How do you know which one to populate? So you would look at this hierarchy that's shown here. Now, if you have, let's say, two state routes that are intersecting at a traffic circle, the lower numbered route would take priority. So what does that mean? Okay, so I have two examples here in your state. So on the left side, as long as there's no local 911 name like Main Street, this is where everyone, see if you're paying attention. If you go to open up your chat box, we have State Route 27 and US Route 63. Which one do you think should be placed on the street name fields? You have two overlapping routes, no local street name. Which one of these two should you populate on your road center line? I'm looking for someone in your chat box. So either 63 or 27, which do you think? Got some votes for 63. Anyone else want to weigh in? Okay, so you're correct. It is 63. 63 is a US route, which it's a higher jurisdiction than the state route, which comes lower. Now let's look here where we have two state routes, 27 and 77. In the chat box, write down, do you think 27 or 77 should be put on the segments where both routes are crossing over it. And so we have a whole bunch of folks that are saying 27, and that's correct. And that's because of this note down here, that the same hierarchy level, the lower number takes priority. So this actually is very common in the state DOTs. A lot of them use this type of a hierarchy, and that's originally, I think, where a lot of our discussion focused on. So we have a little bit of time. I want to take a look at some examples of roundabouts or traffic circles. And instead of me talking through this, I think what I'm going to do is go right to the traffic circle and walk through it, just because we're also getting to the end of the time. Again, these are all detailed in more in the document. But here, when you have roundabouts and you have two local roads that are intersecting, and in this example, we have Watts Road that's running east and west, and we have Sugar Maple Road running north and south. And since they are both local jurisdiction and they're both going over all these segments, what you end up doing is looking at their traffic rates. And since Watts Road has a higher traffic flow than Sugar Maple Lane, Watts Road will be populated on these road center lines. But then Sugar Maple Lane, as you can see over here in the table, is in the alias street name table. So that's how you would handle that one. And again, I'm going to skip over the text and we're going to go right to the example because it's much, much easier to look here. So in this example, we actually have a road that's dead ending at a roundabout and traffic circle. So in this example with East Sherrill Parkway running east-west, that's the primary route. What you end up doing is the roads that you take to get from one side to the other, those are going to be populated with East Sherrill Parkway. Now this road that ends here, there's no hard and fast rule as far as do you stop it here or do you continue it through? And in our discussions, we thought that it would be a best practice to go ahead and continue it through so that for routing, when you're talking about going on Fahey Glen, you have to enter the traffic circle on this segment in order to get to East Sherrill Parkway and travel west. And the same thing is if you're on East Sherrill Parkway and you're traveling south onto Fahey Glen, you have to get on this road. So these intersecting roads here would end up getting the name of the road that dead ends. And as you can see over here on the right in the alias street name table, those same two segments would have East Sherrill Parkway as an alias name. Now we're going to just finish up and talk briefly about site structure address points. So NENA, first of all, has a very detailed document. It's about 60+ pages long on site structure address points. It has lots of details, tons of graphics, and it talks about where do you place an address point. And it's based upon these 5 different address point placement methodologies. And that document also includes a lot of guidelines for creating and placing sub-address points. So if you're looking to expand on that, rather than replicating all that information in the Wisconsin document, we recommend that you cite and take a look at that particular document. And it's really a great resource to visually see the address point placement methodologies that are out there based upon whether you're placing it from a geocoding data set, if you're doing it based upon parcels, a site, a structure, or it's a property access. So I talked about property access. What does that mean? So address points are typically placed on the feature that's being addressed, where an access point is where you go onto that site or into that structure to get to the address feature. And then if you have like a large structure site, particularly those that have multiple entry points, it's really a lot of times beneficial to have the address point not only placed on the structure, but also at the entrance to that property. And those are the access points. And those can be really useful for directing the emergency responders to a structure that might be located far from the road that it's addressed off of, or maybe it's one that shares a driveway with many of them. So sometimes it's useful to provide both that address point and the access points. And if you do that, you want to make sure that your access point has the exact same attribute values as the attributes that you put on your structure point. The only thing that should be different is the placement method attribute that's populated differently. So let's take a look at one of these. Here's an example that we have 4 properties that are being addressed off of the East Blue Mounds Road, and they share the same driveway. Now, most are far from the road and they're probably not easily visible. And in fact, in the lower left, you see address 1983, sits even further behind another house, and it's definitely obscured by a lot of vegetation. So if you only had address points in your data set, the responder would really have a hard time knowing exactly how to get to it. So if you only had address points just at the driveway, the responder would say, okay, I got there. Now I have to figure out which structure is it? How far back do I go? So this is a good example of having both points shown. And when you place access points, such as at the driveway entrance, you want to offset them a little bit from the road center line, but put them in the direction of increasing addresses. So they're next to each other, but they show and go along with the address flow. And then again, don't forget to populate the placement method attribute field so you know the type of point it is. So another situation you may run into is what happens when you have a single structure and you have multiple addresses or units within it. So you're going to see these at your shopping centers, condos, apartments, etc. Sometimes they're going to have their own unique address number, 10, 12, 14, 16. Sometimes they share the same address number and they're only differentiated by their unit number. So they're all at 12 Main Street, but you've got unit 1, unit 2, unit 3, or etc. So the placement for these should be based on whether the entrances are separate or shared. So the goal is to be able to get your responders to the correct building entrance. So you want to place the points at or near the building entrance. And you want to use stack points at shared entrances, since you usually don't know within a building where an individual unit is located. Although, once again, check with your CAD requirements because not all of them let you use stacked address points. Now you want to also place the points within the building footprint so that if the imagery shifts in a future release of new ortho imagery, that point will still be close to its original entrance. You have to remember, we're all GIS professionals, we're all very picky, and it's really hard to quell back our urge to move a point back onto the front porch. So this way it kind of helps minimize that happening. So let's take a look at an example. And this is a shopping center. And each of the units has their own separate entrance, and they also each have their own separate address number. You know that they're separate. You can see a lot of different vents on the roofs, and you can also see in some cases where there are little covered areas going into some of the main entrances. Now, because the ortho imagery, again, could shift, it's recommended that we put the points a little bit inside the building footprint, but near the address entrance for that particular unit. Now in this example, this was kind of a unique one that we stumbled upon. We have 2 buildings. They both share the same address. They're both 801. But each building also has different entrances, and they have different apartments that are numbered in their particular building. So in this case, what you want to do is get those responders to the correct entrance so you can stack their points at the appropriate building entrance. If you know where those individual units are within, you could go ahead and put those points directly on the units and then create access points into the structures. But in most cases, you really don't have that level of detail, and trying to obtain it can be very resource intensive. So what do you do in the situation where you have multiple structures or sites that, getting tongue-tied here, that share the same address? And this is common when you have like a medical campus or a large college campus, office complexes, mobile home parks, campgrounds, where you have all these different sites or buildings. They all share the same primary number, but they're only differentiated by their units. So again, the goal is each building or subsite should have its own address and subaddress information that distinguishes it from the other, and that's so that we can get the responder to the correct building or subsite. So when it's going to help the responders, you might want to be able to create a property access point as well as put a point on the individual structure. But when you create that property access point, because it's going to all these different sub-addresses, only populate it with that primary address number. Don't fill in the sub-address fields. And you're going to place it at the primary access to that property. And then here's an example where we have this unit area, and it appears to be a mobile home park, and they're all addressed off of Wedgewood Drive. So all the structures on each driveway share the same address, but they all have different unit numbers. And so in this case, we have all the numbers here, and then go on to the right from 1 to 10 have address 1325, and they're differentiated by these subunits. So we created a point at the beginning of each driveway as an access point with the main number, and then each of these would be 130. This example, this would be address 13575 Wedgewood Drive, unit 32, unit 33, etc. So that gets folks at least to the correct those 3 driveways so they can quickly respond to those points and addresses that are there. And then sometimes you have multiple properties that share one address. Think of a large farm. It may span across the road, have lots of parcels. You want to put the point on the main structure, regardless if the address conflicts with the address range. Jessica talked about having an exception flag on that. And then if you don't have a structure, you want to go ahead and place a parcel point to avoid parity conflict. And then we also have the situation if you don't have a known driveway or main entrance into it, there could be an entrance used to get to a specific feature that you get 911 calls to. It could be a fishing pond or swimming pond the kids go to, or a hunting camp. And then to wrap up our discussion today, military bases and tribal relations. They may or may not have their own PSAP. And it's pretty common that they will share their street names with you, but not usually their address information. And if they do share their address information, they may have some restrictions on it. So they may say, for example, you can only use it for 911 operations, not for public sharing at all. So make sure you know the guidelines. And if you really are having difficulty working with them and trying to get information from them and they're not responding, it's recommended that you contact the Office of Emergency Communications within the Wisconsin DMA, and they'll assist you in getting those contacts going. So with that, I think we're about at our time has come up. And so I want to note that we have this educational session scheduled for 4 more. It's going to be a little bit longer. You see it says 10 to 3, but we are planning an hour break for lunch and split the presentation into more. We'll get into a little bit more details, do some more details with address parsing. And you're all invited to attend any of them. While the first 3 are kind of goal is to have them be regional in nature, there's an open session as well, but feel free to attend any of them. And I'll put up
And
the
these
last.
would be a really great forum to answer any, if you have more questions. I know we're short on time here, but if you have more questions for both Cheryl or Jessica, if you wanted to attend these, this would be a great forum to do that.
Exactly. And if you haven't reviewed the standard yet, take a look at it before them. You'll might have more questions that come out of it. And of course, here's our information. Jessica had indicated if anyone had questions about the results of their QA/QC work that they did, she'd be happy to get the reports and information to you. And with that, I think we're all set, Fred.
Great. Thank you so much, Cheryl. Also, thank you, Jessica. Everybody else, enjoy the rest of the conference, and we'll be in touch. Thank you so much.